Hello again, Lurks. God damn, those wasabi peas are hot. So I have a question, because what does it mean if, can I select stuff on here? So it says a virtual console is unused if it is not a if it is not the foreground console and no process has it open for reading or writing and no text has been selected on the screen, right? So that would make you think, right? I mean, it depends on what a process is, right? But if I jump over here to this other TTY, all it has is like the login like dialogue thing ticking, right? So then if I do, actually, what are the options here? Okay, so if I do dialogue DT, it looks like nothing changed. Although, how do I tell, right? What if I say, see, it says device or resource busy. So that's probably what this was saying here about a process probably has it open for reading or writing, is what I'm guessing this is. Why I'm getting this error. but because it's probably like whatever the init login process is. What I want to know is how can I see what process that is? Maybe if I run htop and sort by TTY, I can try to find whatever happens to be running on TTY2. Oh shit. Okay. So what is this? /spin/a agent. A getty. Age TTY. Okay. Age TTY. What the heck is that? So let's see. Tmux new session s LFS. Okay. Whoa, wait, that's not right. Okay. So let's see. Let's figure this out. Oh, hey Chutoy, how's it going? Okay. What is a getty? Alternative Linux agent. Is that really the size that normally is? Yeah, that's what I thought. Opens a TTY port, prompts for a login name. Exactly. Okay. It is normally invoked by init. A getty has several non-standard features that are useful for hardwired or dial-in lines. Dial-in lines. Actually, what were those options there? So some of them were, what is it, -O? Oh. Okay, login options. Options and arguments that are passed to login. Oh, makes sense. What else is there? Okay, login pause. Wait for any key before dropping to the login prompt. Now, what the heck does that mean? I'm guessing what that means is that maybe what counts as a key is Control-Alt-F. You know, so then that would be like what starts it. Although, wait a second, huh? There's nothing here in quotes. What the fuck is /u? Oh, fuck. Okay. Oh. Okay. Where /u is replaced by the login name. For example, login options. Where'd it go? Oh, here it is. Okay. So you pass in P. No more arguments. So actually, is the P an argument to HTTY? Or is it an argument to login. It is past login. Oh, so I need to be reading the login man page. Oh. Okay, this probably makes more sense. Preserve environment. Okay, and then no clear. Alright, I have no idea what that is. Although maybe this is something. Yeah, I don't get it. So since I don't know how it works, let's just break it. So let's kill it. So let's, can I not kill this? S. Doesn't S mean you can kill it? Like interruptible or whatever. Nothing. I mean, I think this has like the set ID, whatever, but let's see. Alright, 18382. Literally nothing. Oh, well, it did kill it, but it just, wait, what? Oh, yeah, nothing happened. Oh, no, another one fucking started. What? Oh, because I switched to T2I3 accidentally. Makes sense. 18422. You know what? Fine, fine. Okay, so once I log in, it probably hands off ownership, is what I'm thinking. So you can't see it right now, but I'm on the T2I trying to sign in. So, okay. So now if I switch back, what? It's still running. So it's not like an exec thing. I guess it's just running there in the background, but then why is it running for T2I1? So because it's auto login? Oh. Okay, let me just like kill it and then see if it's still here. /bin/ Okay, that actually does kind of make sense because that's what HTTY ran, that command. Although I don't know what the fuck no clear is or any of that shit. Oh, those are more options to HTTY is what I'm thinking. No. Oh yeah, yeah, actually. And then bash is being run, and that's also it's running on T2I1. Okay, but we know T2I4 isn't being used. So let's do KBD. Okay, this is graphics. Now if I do open what's it opening on? I should have read the man page first. Start a program on a new virtual. OpenVT will find the first available virtual terminal. Send this schedule before and run it. Run on it the given command with the given command options. Standard input, output, and error directed back terminal. Search path. Path is used to find the requested command. If no command specified, then the environment variable shell is used. Cool. Switch to the new VT. Is this how like start X and similar things work? How like you I'm not making it, but like how start X you do that, and sometimes it will open like another T2I, like T2I7 or whatever by default. Although that's not what I have on here. Maybe that's it. Like what that uses. Like it uses the T2I and then switches it. Maybe it uses C or L. What's L? Be a little bit more verbose. Wait for command to complete. If W and S are used together, then OpenVT will switch back to the controlling terminal. That's exactly what happens when you like in Debian or something. If you kill the whatever it is, it'll switch back to the first one. Like if it exits unexpectedly. With the get out long and you wish to set options to the command, you must supply the end of options flag. So to start this out, use OpenVT to get a long listing. Okay. So I'm guessing that means it's 4. Sick. There it is. You can't see it, but trust me, Vim is open on number 4. Oh no. No, it's not. Let's try running that again. Oh, that's so sick. All right, back to here. Hey, LC Pablo. How's it going? Yeah, so I'm just messing around right now, trying to understand some of the more core components um, of Linux and then I'll actually get back to making that OS once I get a real life viewer or once I want to. But so if you're a real person and not a bot like everybody else that is in the channel right now, then I will get back on to work. I just thought of a good idea. It's always been a big hassle trying to look at the chat. Well, not a big hassle. It's actually pretty easy. But can I look at it on my phone? Does that work? Whoa, mobile live dashboard. Whoa, what is activity feed? 1 viewers. And there it is, chat. Cool. Oh, well. Nice. So let's try this again. So instead, I do the SW. I could say hello there. You can't see this right now, but if a real person shows up, I will show it. And then I quit, and it comes back. That's so cool. So I wanted a faster way. Okay. I gotta figure out a faster way to do this. Okay. U is user. What would be the best way to do this? Alright, this is gonna get crazy. Now this is running as root, right? Who am I? Yeah. How do I get out of here? And then I exit, and I'm back. That's pretty cool. You did deallocate it pretty well, though. Don't worry. Okay, but now how can I do this as a different user? Because what if I want to make it as a user that's not root? I can use the -u, but this says and run login as that user. So what if I want to use the U option, but not run login? Like, can I do that? Oh no, that doesn't work at all. Yeah, so that doesn't seem to be working. So does this mean OpenVT can only run? Figure out the owner. Oh, and it's also figure out the owner of the current VT and run login as that user. Oh. Oh man, that's so gonna work though. So I can't. And you also can't run this command as not root, right? So I couldn't just say OpenVT. Yeah. And I can't just say OpenVT. What the? Wait, what's the meaning of that? Okay, yeah, SW. Oh, it's the owner. Okay, I already knew this. It's the owner of the current virtual terminal. All right, I'm gonna stalk my viewers for a bit. So Elsie Pablo, I'm a bit confused because it doesn't seem like you're a bot like everybody else. I mean, it seems like you're learning Python. That's pretty cool. You haven't streamed for a few weeks though, but it's so annoying that there's ads now on Twitch. Like for people that have Twitch Prime. Oh, what editor are you? Oh, is that VS Code? Cool. I like VS Code. Oh, that's sick. Window manager. Huh. Anyways. So moral of the story, you can only run OpenVT commands as root or the current user, which makes no sense. right? Unless I can chain it with other commands. Like I could do, and then run the command. Now let me do this first. Okay. And then I can do su. If I do this, like LFS and then a command, like a user and then a command, I know, like with bash, it would run the command. I don't know if this is going to work. So this actually didn't do anything. I'm literally looking at a blank virtual terminal here. Oh, shit. All right, let me try that again. Hey there, Zach. How's it going? Right now I'm just doing some messing around trying to figure out more about how this works at a low level, and you can't actually really see what I'm doing since I'm working on another T2Y right now. But I'm just messing around waiting for a real person to come into the channel to actually like convince me to start working again on the OS. So if you're a real person, just say hi in the chat and I can show you some cool things. Yeah, this isn't working out. What does the login command do? What the heck? Okay, all I want to do is start a display server on another T2Y as another user. And I don't know how to do that. Okay, so that's cool. You know what? How the Okay, so that didn't work out as I had hoped. Don't make me resort to Google. No. I'm gonna Google it. Is Linux a command? Hello? So what does it mean to do? Is that the term? So that's what it looks like it's doing. HT2I isn't indebted anymore. Cool. Cool stuff. Okay, let's get back to work. So let me go ahead and CH it into here. And now you can see what I've been working on for the last, oh geez, way too long. Actually, not way too long. It's been a lot of fun, but so here you can see the LFS CH. This is my Linux from scratch environment. And I am still working on. And hopefully we can make a lot of progress today. So now what we're going to install is that we're going to, so the next thing that we got to configure and build and set up and all that stuff is procs, geez, I can't speak right now. Proc PSNG. And what proc PSNG? So it's proc PSNG. What this is that the proc PSNG package contains programs for monitoring processes. Like, as I'm sure you know, there's like the PS command, that'll show you all of your processes that are running. Similar to like top, like to top or htop. Obviously, none of them are on here because I haven't gotten to it yet. But we're about to go ahead and install the proc PS stuff. So to do that, I'm going to go to my sources folder. Let me just make this a bit nicer. Oh no, what are the ls? What's the name of that ls options? I literally just saw the sort option. Do I have to escape it? Oh, I have to start from the beginning. Yeah. I thought there was a way to... group directories first. Group directories first. Color. That's what I'm talking about. Now we successfully installed Vim yesterday, so yay! So I don't need that anymore. So Pablo, you know what? I'm gonna go ahead and follow your channel because that actually it seems like a cool stream. I like streams where like people are like learning stuff and like along the way, because then like I can learn stuff too, and then they can help me learn stuff, and then hopefully I can like even help them, like the streamer, learn stuff. All right, so we're gonna do the. Okay, so. So what sorts of options do we have here? Okay, to assign, yeah. So we have exact prefix, vendor. Okay, all the basic stuff. PS, that's for PS documentation. Okay. Program prefix build. Wait, is PS like a file type or? It's next to PDF and DVI and HTML and doc and man. Okay, whatever. Disable option checking. Okay, what kind of features we got? Let's see what files we want, or features we want, I'm sorry. Okay, so some of these we already have installed, and we've written and compiled these like on our own. So we don't need to compile them with whatever version is in here. So we're not going to need that. We will need to specify like the libdrs and the doctors, and then we also don't want any static linking since we just went through all of this time getting all our dynamic linkers to work. So, actually, let me see something real quick. Hang on. What is the install architecture dependent files and ow. Okay, so we don't want to install any architecture dependent files since our kernel is sort of up in the air right now and we're like ch rooted and stuff. So so if you just put equals, right? Because normally you put equals and you put like a value here. If you say equals and nothing, it'll set it to nothing, which means it's not going to install anything that's architecture dependent. MG 3.3.15. We don't want any of that static linking. Ugh. Because we're dynamic linking out the wazoo, and we don't need kill since we already have that. All right, and let's see how long it takes. That's kind of uncomfortable for my ears. I'm gonna see if I can change the sound settings on here to still get the input to come through the mic, but then the output to go through the speakers. Okay. So now, hopefully, I'll be able to hear you guys and not hurt my ears. Cool. If there's any echoing at all, though, because it's coming out of my laptop and into here, I'll tough it out with the headphones. So let's make this and use all the threads. If we want to monitor what's going on, we can just go up here in HTOP. Look at that. Full thread usage. Oh, is it finished? Yep. All right, 16 seconds. All right, so I actually have to fix some of the tests here. Ooh, community showcase. What's up, community showcase? I'm guessing you're not a real person, right?
Moderators are awesome. They're helping you build a community.
Show the ones who has your support and good things can happen.
When I first heard that Miller Lite was choosing to support,
is this a scam, Mr. Community Showcase? Like, why are you in my chat right now?
It's a really cool thing to see. So thank you. Cheers to the moderators.
So hopefully you're not going to make me pay anything, but cool that you're in the chat. If you're a real person, then welcome. Finally, Siri plays nice with Spotify. That's what I'm talking about. Alright, we gotta edit some of these tests. What version? 3.3.15. Alright. So we're gonna fix that. We're gonna do set. We're not gonna set T. Why are we gonna set the TTY? Remove a test that fails when scripting does not use a TTY device and fix two others. I don't know. I feel like I can just. Let me try running it. And then see what happens. I mean, if something fails, yeah. What are you talking about? A passive flying colors. You know what? I'm actually gonna. There's a fucking fly in here. No, I'm gonna do this over again since it was so fast. I'm gonna recompile this. I think the configuring took longer than the actual compiling, which is, I mean, I guess that's good because that means it didn't take long to compile. Goodbye, community showcase. I guess I lost my opportunity. So this only took like what, 16 seconds? That's good. So I actually don't really see your problem. Let's say I run these, or let's say I put the K flag in here too. Yeah, I don't think this does anything, but I'll flatter the authors anyway and remove these files and recheck it. Yeah, what are you talking about? Alright, whatever. What is this? Okay, installing. Oh, shit. What was that red thing? Oh, warning. Has not been installed. I don't want it there. I think. Why didn't you install it there? libproc ps. Okay, I'm being annoying right now. What is this lib? What does it say that wasn't installed? .la lib. Why weren't you installed? Probably fine. Well, let's just run it, right? What does ps actually do? Like, what is the ace? Oh, shit. Yeah, there's a lot of... How do I... To see every process on the system using BSD syntax. Oh, so A is all? No, it's not. What? Why the fuck is some of it with dashes and some of it not with dashes. So if I do PSA, does that print everything versus PSE? Is that like the BSE syntax bullshit they were talking about? No, but there's like way more here. So it's not just the format. So versions of PS accept Unix options, which may be grouped and must be preceded by a dash. BSD options, which is grouped and must not, which are preceded by 2 dashes. See? That is useful. So that answers the question. So Unix options don't have a dash. BSD options do have a dash. I mean, BSD options don't have a dash. And GNU options do have a dash. Okay. So A, list the BSC style only your self restriction, which is imposed upon the set of all processes in BSC. Okay, so if I do PSA, this is everything that's owned by me. Is that true? No, StartX is not owned by me, although it could be the same root as it's not in here, which would make sense. Okay, and then what does you do? Select. What is this PSU? And then PSA. You know what? That's kind of cool. I like this. I like this command. Jeez. My fans are like going so hard. I feel so bad for them. I don't know how to help. So OBS is really only using 1 core, which surprises me because I thought that like streaming was supposed to require like, all the encoding and stuff like that was supposed to be a bunch of cores. Right? And that's why like streamers get like they'll get like streaming computers with certain CPUs. But actually, it's not really. Yeah, that's interesting. Memory. It's not using any memory really. It's probably using hella network though. Yup. So what I think I'll do, what about using the GPU? Like, does it require high performance? It is using the GPU, which is good, right? Can I see the utilization somewhere of the GPU? Oh, that's great. That's great, actually. I see. So I think a lot of the fans are coming from the GPU. Cool, cool stuff. Hey, Community Showcase is back. How's that going, dude? You trying to host me, or like, is this like some weird way of like advertising? I don't know what that deal is. All right, let's get back to work now. All right, so just in case user isn't mounted, I'm gonna move the essential libraries to a better spot. .so.star to /library, and then it's gonna be lib proc ps .so. So what we're doing here is that we're linking. So we're moving those libraries from userlib to just lib. And then we're making a symlink from one of those back to lib. But my question is, why are we just symlinking one of them and not all of them? You know what I'm saying? Like, why? You know what? I think I know why. They're probably like are all hard links to each other, right? That would explain it. So if I do ls/lib/lib proc cps.sl, actually, oh wait, I never even moved that one. I never moved. This is weird. I actually never moved this file, right? Because I moved all the ones that had dot in it, which means that /user/lib. Yeah, obviously, because I'm calling this here. Whatever, too late. Okay, contents of PR proc psng. Okay, so this actually installed a few programs, not just PS, which is like the most famous one, but also free, right? So now we can see how much free and used memory we have on our system. I can hopefully look at this in a more human readable way. What's interesting here is that even though I'm on the chroot like environment right now, so it's supporting all the memory, like the RAM from the whole system, which makes sense because I don't think chroot would change that. What I do find interesting is that it's using the swap, right? Because this is using the same swap as the main Raspberry Pi. But how does it know where that swap partition is? And I think on Raspberry Pi, it's not actually a partition, it's just a file. So how can it access that file where that swap is? And it says it's using 0 bytes, which might make sense. I mean, I'm hardly using any memory. If I were skeptical, I could look and see if that's really the case by using free here. Now it's telling me the truth. Okay. Oh, hey, Blunt Test. How's it going, dude? Sorry about that. Didn't see your message. I don't know when that came in. But what's up? You are the first viewer of the day. and like the 6th viewer ever in my channel. So that's quite the honor. The reason why is because, right now, I'm just might seem like I'm just doing some stuff in the terminal pretty boring, but in about 6 months from now, I'm going to be bigger than Ninja. Just as a heads up. Ya boy. Haha. So do you do any like programming? Do you know any like programming, or have you ever used like Linux before or something? This goddamn. Um. Oh, cool. Let me. All right. So now I'm gonna do a brief aside because something that I am interested about is that here I'm in a CH root right now, which means that what part of the OS are you working on? So right now I am tidying up a lot of the user space elements of the OS and about to move on to actually making the kernel. But I'm doing some really cool. Oh wait, have you used Linux before? You said you can program. Do you know anything about Linux? Because that'll help me figure out how to say things. And if you do, I mean like, oh yeah, have you used Linux before? Okay. So do you know like the PS command in Linux and those sorts of things that tell you information about the system? Well, up until like 5 minutes ago, my OS couldn't do that, so I just set up and I'm making a bootloader to just write to screen. Okay, that's awesome. So then you definitely know. Well, I'm guessing you probably know about like those sorts of commands. Well, they weren't on here before, so I just set that up. So I was just showing how I can use like the free command now, and that looks just like how that should look, or PS, or all this stuff. So, oh, and clear, I actually just got that to work earlier too, because that's actually not like a bash built-in, which surprised me. I think. Is it? Yeah. Okay, so that's a good question. What you see right now, like the LFS CHR thing, this is my OS that I've written. I started this with literally a blank SD card with nothing on it, right? And from there, I've gotten everything you see, and more so, every single file or command or anything about this, there's not a single thing on here that is precompiled. So all of this stuff I wrote / compiled from source. And it's taken me a very, very long time to go from a blank SD card to what you see now. It's been way over 50 hours at this point. It's been a really big project for me. So, but you might see like the little window border and be like, wait, did he make like, is he running in a window environment right now? No, this is I'm SSH'd into it from my Mac right now. So actually, the reason why is because I can't stream from the I'm making this on a Raspberry Pi, which is also like another cool thing because I've never had a Raspberry Pi before. So I just got the 4th gen with the 4B with the new faster processor and more RAM and USB-C. But I can't like stream from it. So actually all the work that like you see me doing right now, I'm actually doing like the Pi itself is like right here. I don't know if you, but yeah. So there's like, and there's like the keyboard and all that stuff. So I'm actually working like remotely on, like I'm actually doing the work on the terminal or on the Raspberry Pi itself using like the keyboard and mouse and all that that's connected to the Pi. But so you guys can see it, I just SSH'd from my streaming laptop into the Pi, and then I'm using Tmux to show it. So that's a great question. So how does this work, right? Because I told you I started with a blank SD card, right? But how do you actually like go from a blank SD card to this, right? Because it's not like it's not like the XKCD comic or anything. I didn't take what is it, a magnetized needle and a fine hand and just flip the bits in there. What I've done, so what you do is that in order to start building this, right? In order to start this, you need another computer that you can begin compiling the very beginnings of the tools on. And the thing is that you see me here like actually like running this right now. I wasn't able to get here to run this until like maybe like 40 hours into it. So this is like a pretty new, and I was like, I was so happy when I finally got Bash, because obviously I'm using Bash right now. So Bash is like the last thing that you can put on the SD card that will then let you like load into it, because you can't load into it before that. So I was very excited. But you have to use another system. So you need like a very basic compiler. So actually, I'm trying to figure out how to say this. I've had to say this a few times and I can't exactly figure out the best way to say, but the very, very first thing you do, well, actually you spend like a bunch of hours at first just setting up like the environment on the host machine, like the machine, not host like a VM, but the your second Linux machine, right? Because you need a blank SD card and a Linux machine, is what I'm doing for this project. Oh man, I'm getting lost here, but so at first you spend a bunch of hours getting like the environment and stuff set up, and then the first thing that you actually put on the SD card, right? Well, you actually have to format it and do some other things, but once you once you do that, the very first thing that you do is that you make an assembler, right? Because that's what you need to make an operating system, is you need an assembler. So I make this assembler, but this assembler is not like it's not a great assembler at all. It's a really bad assembler. It can only do very like basic things. It can't it hardly has any features, and with that, and with the assembler, I can make some like very basic other tools, right? So it's a crappy assembler, and I use this crappy assembler to make a couple other like crappy libraries, and like some like a basic static linker that can do a little bit of static linking. And actually, let me looking at my notes. So that's the first thing that you make, right? So just like an assembler, and then like a symbol lister, and then like an obj dump type stuff. And once you have that, so once you use your shitty assembler and a couple of other shitty things, you can use, and all of the stuff is on the SD, right? So the first thing that I'm putting on the SD card is a is an assembler, but I can't actually, but this new assembler that I just got, I can't use the assembler without like an operating system, right? So I have to put the SD card in the computer and then run that assembler from this computer. So from this computer, I can run that assembler to make those other things. But once I have that assembler and made some other things, I can finally go and make GCC. Now GCC is like a huge first step, because now I have an actual compiler, and that's really cool. But this GCC, right, is not like any GCC. It's the worst GCC imaginable. It doesn't have C++. It doesn't even have the C standard library. Like there's no glibc at all, right? And then you may ask, like, wait, what is C without the C standard library? And the answer is not much. So I make this compiler, I make this GCC, and it's not, and it's a very bad compiler. Think of it as like a blunt instrument that doesn't have any, as a blunt. This GCC is just a blunt instrument that doesn't that can't do much, right? It has no linking capability at all, right? It can do like some sort of static link, but dynamic linking out of the question, all that stuff. And from then on, but what do I do with this basic compiler? Well, even though it's a bad compiler, can't do very much. At least it's a compiler. So from there, I have this awesome tool. So I can go and start making other things that weren't possible before this. And I can go and, but what is the first thing that I do with this compiler? Is that I actually go and I remake the assembler. I recompile. I make a better assembler. And the reason for that is because at first I didn't have the ability to have a good assembler because I didn't have anything. But now that I have a bad compiler, I can go back and I can remake that assembler and all those other like bad like linking tools that I made before, et cetera, and like those symbol tools. I can go back and remake those a lot better than before. Because and then so I can go with this bad compiler. I can remake the stuff from before but better. But also now that I have this compiler, I can make things that I haven't made before. So with this GCC, I can make cool stuff. And after I do this for a while, so I make a couple things that I haven't been able to make before, namely like the C standard library, right? You can actually build glibc without glibc. So with this compiler, I can go and I can make glibc. With that, I can make a very rudimentary dynamic linker, and a couple more things. And from then and once I have all of this stuff, I now have remade everything from before and have a bunch of really great new tools and libraries. So what I do with that is that I remake GCC. So that GCC that I made before, let's call that GCC pass 1. And I can make a second pass of GCC. But now it has things like glibc, right? It has, and everything, all the tools that I made with this first version of GCC, like the glibc, all of those different tools, right? Those are all statically linked because this compiler, that first GC, could only do static linking. But now I can make a second compiler, right? And this compiler is made with one that can only do static linking. So this compiler is statically linked, but this statically linked compiler the second one can now do basic dynamic linking on the things it makes. So you guessed it, the first thing I do with the second pass of GCC is that I remake everything from before. And now I can start making some really cool things. But before I do that, I remake I remake the assembler, all that stuff, all the bin utils, right? So I go all the bin utils. I make a better linker. I remake glibc, and then and one of the last things is that I set up a bunch of stuff like things like, and now I start with the second pass of GCC, I can start doing some really cool things. So I can make like I can make things like readline or ZLE, and finally the one of the last things is that I actually make bash, which was sort of recently. And that's really, really cool when I get bash. But actually, if you just have bash, it's not usable yet because you need some more things once you've installed bash. So things like Bison or like core utils, because things like ls is not part of bash. It's not a built-in. So you have to so before I can actually start using bash, I have to make some more things like the core utils, etc. And after that, and some more things, I can actually go into this blank SD card, and I can run the bash on the SD card and have this new environment. And in order to do that, I use chroot. Have you ever used chroot before? Like, do you know how that works? So what chroot does is that on your system. See, I should be doing more like typing so you can I can show you guys things. But as you know, the root of your file system is /, right? The / directory, right? So what the chroot does, which is actually just a system call, as you guess, it changes the root of your file system, right? So now instead of things being referenced however they were before, now everything is referenced relative to whatever you specify here, right? So if I did something like chroot bin, right? I don't want to run this. But what would happen is that if I did chroot bin, right? If I press if I press enter here, right, and then I did cd / and then ls, it would say bin, right? And then if I wanted to access like the dev folder that you can see here, oh, thank God that didn't actually run, because you have to, because there's no /bin/sh in there. I have Linux in mind for this because I'm gonna be making like a Linux this is gonna be Linux based. So even though I'm writing everything from scratch, I'm gonna be like, and even though I'm gonna be like compiling my own like Linux-ish kernel, like it's still gonna be like I want it to have some grounding and things in some standards that are real. But anyways, so if I did chroot bin, right, then the root would be the bin directory, and I wouldn't be able to access like the dev folder or any of the other folders. I wouldn't be able to access it. So what I do is that so now I'm also, the host system was also a Raspberry Pi running another operating system. So what I can do is that once I have bash and those other necessary requirements, is that I can chroot into the SD card, right? So instead of just setting like a regular file on here, I can just mount another file system, right? And then chroot into that. So what you're seeing here is a me chrooted into this new file system. So the thing is that running processes though will still be running after you chroot. So to answer this question that you asked me like a long time ago, you asked that I've already set up SSH and all that, and that's really cool. I actually haven't set up SSH yet, but I just SSH'd and then mirrored the screen, right? Or like used tmux to mirror it, and then I used chroot, and that let me. So now I have SSH, but I'm in here. I actually don't have like real networking yet. I've been working on networking now. Like there is like some things, like if I do IPA, you can see some things, but the networking actually doesn't work yet. Like if I do I actually installed ping too, but ping doesn't do anything. If I do ping google.com, it'll say unknown host because I haven't set up like the local host and all that stuff. So I will get to that. Anyways, so some of the other things that I just installed, like right as you're coming into the stream, is that I installed so free to see how much memory we have. I installed pgrep, which looks up processes based on their names and other attributes. I installed PID of, which reports the PIDs of the given program. So if I do PID of and then bash, right? So these are all the PIDs of all the processes running bash. There's pkill, and which signals processes based on their name or other attributes. Pmap, which reports the memory map of the given process. So pmap, here you can see, very cool, all the memory in this. What $$ does, I don't, depending on how you've used Linux, what $$ does is that just reports the PID of the running process. So if I do pmap $$, this will map out the memory of bash, right? Because obviously I'm in bash right now, so $$ 24692 is the PID of bash. PS lists all the running processes. PWDX, like PWDX, right? So PWD, as you might know, prints the working directory. So PWDX lets you specify a process, right? So you could do is init on here or whatever. No, oh no, I haven't installed init yet, and you have to put the PID. So whenever I do any testing with PID, I only use bash because that's the only ID that I know of. Although now this is great because since I just installed PS, from now on I can actually I can find PIDs of things. I haven't been able to find PIDs before, but now I can. But anyways, so no surprise, the working directory of bash is the directory that I'm in, because so that in this case this is the same thing, but you can do that for any process. So there's also slab top, which displays detailed kernel slab cache information in real time. So SL lab top. So that's cool, kind of like top, but it's the kernel cache information, which is pretty cool. There's sysctl, which lets you modify kernel parameters at runtime, right? Which we're not going to do right now, but we will be doing a lot of this. Sort of what I'm doing right now is that so you can make an operating system in whatever order you want. Well, not whatever order, but there's a lot of leeway when you're making your own operating system. So I'm actually making the user space components of this operating system before I make the kernel, right? Because what chroot does is that it doesn't actually change the kernel. You're not rebooting the computer, right? You're literally just changing, whatever slash is, right? So when I'm chrooted into this, it changes, everything is now relative to my, to this SD card that was initially blank and is running everything on there. So it's as if it is practically like I'm booted into this, but it doesn't change the kernel. So the phase that I'm in right now in this operating system is that I'm getting everything ready that I need to start making the kernel. So what I've been doing for the last a few days now is getting things ready for the kernel. So I'm installing so what I'm doing is that I'm writing all the utilities I need to make the kernel. Oh hey Cushy, how's it going, man? Just working on your game. Cool. Sorry about that. Yeah, so he's working on a cool game. It's for he's making it's for his portfolio. So he's trying to make a game that showcases all the cool things he can do. So actually you haven't told me specifically what's in the game, but just that it's for your portfolio and that it's going to be a great showcase of things. So anyway, so things like sysctl, which can modify kernel parameters, I am going to be using a lot in times to come. So tload, this prints a graph. It's cool. It's like an actual graph of the current system load average. So you can see here how this graph is sort of being drawn in real time here. That's pretty cool. Uptime, actually, there's also top, which is this. Yeah, so it sort of shows your CPU usage. There's uptime, which shows how long the system has been booted. VMstat, which shows things about swap space or virtual memory, and then W, which are all the users that are currently logged on, which is nobody because I haven't set up the backend for that yet. And then there's watch, which runs a given command repeatedly and then displays the first screen full of its output. And this allows the user to watch the output change over time. And then a library that I made is libproxyps, or procps, which contains the functions used by most programs in this package. All right, and then something else. So I've installed this. That's cool. So now I'm going to be writing util Linux. And what util Linux is that it's a package that contains like miscellaneous utility programs. And among those utilities are tools for handling file systems, consoles, partitions, and messages. So just it's pretty much file systems and partition tools. And what dictates the standards on Linux for a file? Actually, I think it's like a GNU standard, but for file systems, it's something called FHS. I'm gonna do a pro stream remove right now, and let's see, pro stream remove. Wait for it. Here we go. Look at that. And so what FHS is that it is the standard. That's not what it is. FHS. It's the standard for file systems. So, oh, that looks disgusting. Okay. So this, I'll just read Wikipedia to you. It defines the directory structure and directory context in Linux distributions. It's maintained by, okay. So as you can see here, all of these things are things that are required to be called Linux, since it has, even though these are all like user space things, the kernel will look for a lot of these, will look for these directories, and it's just, but more importantly than the kernel, well, maybe not more importantly than the kernel, but also very important, is that all of the processes and anything that you try to compile or install or anything that you just download from the internet, which I will not be doing any of, but if you were, when you install programs from the internet, they look for directories to do things in. If you need to get like wireless information, to see how well the Wi-Fi is, you need to have proc/net/wireless to get those RSS. So having a predictable file structure is very important, and FHS is what defines this predictable file system. See, that file structure is what I actually hate. Performance-wise, I'm not sure if it's actually better, but I love how Windows is like a main library folder. We can just have overarching dependencies. Then every program-specific library is in the install folder next to the binary. I'm not sure. If you're not sure of what's actually better, I mean, like, are you talking about FHS? That's like pretty like efficient right there. I mean, in terms of like this is kernel stuff, but like if you look at like cache misses and file system lookups on Linux, it's like virtually nothing. Like the efficiency in there, like if you actually look at the kernel code that looks up, that does path resolving and file names, it's incredible. But then you're also talking about libraries. It has like a main library folder where you have like overarching dependencies. Then every program specific library is installed next to the library. Yeah, that's the same thing on Linux. I mean, on Linux, or at least on the distribution I'm making, which this specific thing is defined in the Linux standard, is that you have like you have your /etc/include, or is it just /include? Oh no, yeah. Where is it? I think it's in etc. Or yeah, okay. Well, you have it in a couple places. You have it in etc include, and then you'll also have it in like /lib, which is like a bunch of, as you can see here, libraries. So that's where a lot of these libraries are. But then they're also in other places like /user /include, right? So here's a bunch of extra header files and libraries, I think, are in some of the folders, although this is mostly header files. /etc/ I think there's like a lib thing. Okay, so I mean, you can see here that it's like that there's some that there's a couple of libraries in here, but most of them are in like /lib, I guess, which is kind of like how it is on Linux, on Windows apparently. You have the wrong. Oh, Jesus Christ. You guys are, how have you been? My bad. Okay, that was very not pro streamer of me. I told Blunt Test that in 6 months I was going to be bigger than Ninja. And now making mistakes like these. Okay. My bad. What I was saying is that now you're okay. Although, why is my camera in the back? It should be over here. There we go. Okay, so in slash lib is where all the libraries are, like where all the system libraries are stored. And then in slash user slash lib are where a bunch of other libraries are stored. And then those are the only, so those are where all the system libraries are stored. And then all the user libraries, like for individual programs, if they need a library, that would be in slash user slash local slash lib, which is probably empty right now. Yeah, because I haven't installed any, like I'm installing all of the libraries for the operating system to run. So there's no like, user libraries yet, but this is where they would be. And what would happen is that the structure of this is that in this folder here that's empty, there would be folders for applications that may like bundle libraries together, and then you can also just have like libraries like on the top level of this folder that are for like user programs, and then they're normally tracked by a package manager like after Pacman that would like know to remove them if they're no longer needed. Yeah, sorry about the not very pro streamer of me. Okay, anyways, so let's start installing some of these what was I saying? Yeah, so let's start making these core util Linux packages. So now the FHS, again, that standard, the FHS recommends using the /var/lib/hw clock directory instead of the usual /etc directory as a location for the AG time file, which, as it sounds like, what AG time does is that it lets you like is that it's like a time adjuster thing, but not like date that lets you set the time, but it's more of like a smaller scale time thing. So so again, it wants us to install this in /var/lib/hw clock instead of the /etc directory. So in order for this to install correctly, when we end up making this, we're going to need to make this directory. So we're just going to make this directories. All right, so now let's actually go about making. So what sorts of options do we have for util Linux? So to sign, yes. Okay, so we have the basics like prefix and stuff, vendor. Okay, so some of these are important. Like, well, doctor is going to be nice to install some of the documentation. Program prefix doesn't really matter. Disable option checking. No, actually, we will need that. And then, because that's a nice thing. I mean, when I do this, I have the option of making my OS however I want. So I have to see what I want from here. Well, a lot of disabling things. And I will need to do that since a lot of the stuff, I will have to not do at first because I don't have because there's a lot of circular dependencies in these sorts of things. So this will want to install things that need things that haven't been installed yet already, right? But I can't install those other things yet because I need this first. So to fix that, what I will do is that I will install this without a lot of the features, right? And then later on, after I've used this and a lot of the other stuff I'm going to make and a lot of stuff I've already used to make those other tools, right? Then I can go back and recompile this with support for all those things. So that's sort of a pattern that'll happen a lot. Okay. Yeah, so a lot of these are going to have to go. Like, I don't think I have so I don't have like SU or even like privileges. Like, I haven't really set up like the privilege. Well, I do have some privilege support. So real okay. So I do have I actually do have a lot. So I will be able to compile the support for a lot of these things, and then without support for other things. So um whew, okay. I think this is good because everything else, so all the other features the of Utilinux will be installed except for these, which I think, and I have to make sure, right, that it's not going to install something that I don't have support for yet, because that's going to break things. Even if it doesn't break things, like now, the scary thing is that I hope if I put in a wrong option, I hope it doesn't compile. Because if it does compile, then what can happen is that I can just run into problems like later on when I'm compiling other tools, and it'll give me like these weird error message, and I don't know what they mean, and like it'll take forever to diagnose like this, and then I may, and then if it's been seeding problems, like let's say then the problem may not even be Utilinux anymore. I could have compiled Utilinux with support for something that it doesn't have, and then use Utilinux to make something. So that's then broken. So then I may have to recompile not only Utilinux but that thing that's broken, or that can like chain on, and literally everything could be broken. This is kind of emotional story for me, but I was doing this, and maybe about probably about like 10 or 15 hours in, I was explaining this to you, Bluntus, a while ago, but you do the first pass of GCC, right? And then like 30 hours in, you maybe do the second pass of GCC. So it's probably like 35 or 36 hours into it when I was trying to, some kind of, was it bash I was trying to make, or like read, it was something I was trying to, yes, it was when I was ch rooting. That's actually what it was. Yeah, so I had done bash and like core details and some other things, and I was trying to ch root into it, but bash was giving me these errors, and that it couldn't, and that ch was saying it couldn't switch the root directory, and it took me like 2 hours to figure out what it was. And what the problem is that when I did the second pass of GCC, I wrote the linking thing wrong. So everything that was made with that GCC, the second pass of GCC, was incorrectly linking all of the was incorrectly linking every single thing it compiled. And I was trying to figure out like smart solutions to like change things, but actually I couldn't just change, like I couldn't just relink the things, because some of it was static linking, since the second pass of GCC couldn't really do a lot of great dynamic linking, and also some of the compilation was depending on what sort of linking it did, because it was looking at the linked places, and since it was linking to the wrong things, it wasn't since it was linking to the wrong things, they were being compiled incorrectly. So it wasn't just, so it was bash, and everything else for like days of work had to be totally redone. Well, first I had to fix GCC, and then I had to redo everything, and that was a heartbreaker, because I was like finally ready to like, and I told you I was like celebrating like when I was able to like ch it into it. Well, I was like getting ready to celebrate, and then and then it didn't work. So it's important to make sure that, moral of the story, when you're compiling core things like util Linux, make sure that you're doing it right. I think it's right. And hopefully this will work. And again, if it doesn't work, you hope that it will come out in the compiling or during the checking phase, and that nothing slips by. I don't know why I'm eating these like wasabi peas, but they were just here on my desk, and I've been like just snacking on them for the last couple hours, and I don't like spicy food. So I need to like put these away. I'm not even hungry, and yeah. Wait a second. Why is it not up to the... What the fuck? Oh, come on! Oh, no! Alright. You guys are a great chat, and thanks for telling me when I forgot to switch the scene. That was very helpful. But you did not tell me. I just looked at the stream right now, and you did not tell me that I've been showing the exact same terminal screen for like, how fucking long has it been like this? I've been like doing shit this whole time. Oh no. Wait, why isn't it? Oh, because the SSH broke. Oh shit. Oh, because I was moving my laptop and I unplugged the Ethernet cable. So the Pi hasn't had any network connection. So the SSH thing broke. Oh no. I was just giving you a hard time. It's obviously not like your fault at all. Okay. Man, well that really sucks. Okay, Pi. Man, that... I apologize. How long has it been like that? Okay, hang on. I'm fixing it. No, not that one. This one. Okay. So obviously, if you're just lurking, you don't have to you don't have any I mean, you don't have any responsibilities anyway. I mean, you're just watching. But if for some reason I am typing, you hear typing, and at that moment you happen to be looking, I'm not saying like you have to keep on looking, but if it's like I'm typing and I'm talking about things on the screen and then you don't see anything, definitely let me know, because that would, yeah, that would have stopped a lot of this from happening. Okay, now let me reconnect. Okay, here we are. Oh no, I'm working on Project M. Oh, on a Project RN. RN looks like M. And when you said you were working on Project M, I was gonna be like super excited. Project M is a Super Smash Brothers game, and I thought you were like a developer for that, but not 100% paying attention. Hit me up with the link, would be cool. Oh yeah, send me the link too. Post it in the chat, and I'll take a look at it as well. All right. Well, I apologize. Well, you know what? On the bright side, I mean, you two are the only two people in the chat. So if neither of you are looking at the stream, then it doesn't actually matter. Okay, you know what? So it's all good now, because you guys were only listening to me, so it's all good that you couldn't see. Is this your own domain? Well, I guess so, because it's cushy.itch.io. Oh, is this like your GitHub page? All right, I'm gonna finish up Linux, and hopefully there's not some like serious bug that I have to rewind like 10 hours to fix. Because if not, then I'm gonna play this. Well, I'm gonna play this as soon as I do that. But yeah, what you saw, like all of those disable and without options, those prevent warnings about building components that require packages not in my environment or are inconsistent with programs installed by other packages. All right, so now let's make this. Let's see how long it takes. Okay, but that's like your own domain on this website, which is cool. Cushy.itch.io, and then I can follow you. Oh, but I need to make an account. Well, I can log in with GitHub, so it's not that far from it. Oh, it's Windows. Wait, Cushy, I'm trying to. I apologize for confusing some people. I remember that I did remember that you were the person working on that portfolio game. I don't remember if you were the one that was bullying me into using Manjaro. I forget that. Oh snap! Blunt Test is now following. Thank you so much, dude. That means a lot to me. Like I just started this, and like I just started doing this, and it's it's been a lot of work. Like I've spent a lot of time on this, and I'm trying with the stream. So thank you for the follow. Yes, you were surely the one, and now you're telling me I have to use wine. This is what's wrong with Vulcan or something. Now I feel betrayed by you. Thanks so much. Thanks again, Blunt Test. Damn, these peas are hot. All right. Now, these tests can the tests for this can actually running the test suite for Linux as the root user can be harmful to my system because in order to run it, the config SCSI debug option for the kernel, right? So this is a kernel option that has to be available in the currently running system, and it must be built as a module, as a kernel module. And it has to be built as a module because if you build it into the kernel, it will prevent booting. So for complete coverage, other packages have to be installed first. But since I don't want to do that, I can't run the full test suite, but I can run a selection of the test suite as non-root by first re-owning everything as nobody. And then I can switch to nobody and run the command /bin/bash. All right. So now we're running all the tests. Oh, okay. So what are you doing? Okay, you're using Unity. Unity, unfortunately, I prefer Unreal, but the project is too heavy. for my PC and Unreal. Ooh, that's too bad. So as you can see here, it's skipping a lot of the tests that require root. And this is good because it's a lot less dangerous. Because running this as root would damage my system. So what I'm going to do is that I can rerun this test later on after I've made my own kernel. But I'll have to make my own kernel first. See, look at that. All 201 tests pass, which is what I like to see. Now I can make J install, and we're all good. Man, look at all the stuff it's installing. Okay. Now, util Linux comes with a bunch of different programs, right? And libraries and directories and all that stuff. So, and if you guys are experienced with Linux, you may know some of these things, but not others. Like you may know higher level versions of these things. Like for example, there's addpart here. And what addpart does is that it informs the Linux kernel of new partitions. And you may be saying, wait, don't you do partitions with like fdisk and with like fdisk and then like mount or stuff like that, right? And the reason, and so like what the heck is addpart for? And addpart is a much lower level utility that communicates with the kernel and tells the kernel about new partitions that it has to mount, or that if there are new partitions that exist in a file system. So without a doubt, things like fdisk and mount are using the addpart utility a bunch. So here are a bunch. Again, I'm getting ready to make the kernel, right? So another thing that's going to be important in that is agetty or HTTY. What this does is that it opens a TTY port, it prompts for a login name, and then invokes the login program. So that's going to be important once I'm actually like starting to like boot in and like maybe log in or something. Another important thing is blk discard. What this does is that it discards sectors on a device. This is like file system stuff, mounting things. There's blk id, which will be used to locate and print block device attributes. There's also block dev, and this allows the user to call block device IOCTLs from the command line. There's cal, which displays a calendar, which is kind of cool. Is the date right on here? Monday the 7th. Oh yes, I set a date way earlier. At first, the date wasn't right at all, but as you can see here, the date is hopefully right. 15:58. It's actually, is that right? I think the time's wrong. Uh-oh. Hopefully that's not a big deal. But if I do another pro streamer move, and I find the time in EDT, it's 3:58. Can I get it in like military time? Yeah, so if it's 3:58, it's 50. Oh, that is right. Okay. No, I just don't know how. I'm just a filthy American that doesn't know how things work. Never mind. Yeah. See, I can't see the chat when I'm in the browser. I mean, I could just, but yes. Thank you for looking that up for me. I'm just stupid. Yeah, I know. I was doing that in my head, but I guess that just didn't work. But you're right. I just, I'm literally an astrophysicist, and I couldn't. I, I just had a brain fart there. Whatever. I know how to do things. Um. All right. So, anyways, there's counseling I just installed. There's also CF disk, which manipulates the partition table. So again, I'm just walking you guys through some of the core kernel utilities. Um, and if you obviously this is just like a one sentence explanation of each. If you want, if one of these kernel tools sounds really interesting, definitely tell me and I can go more in depth about how these work and what they do. Right now, I'm just doing like one sentence summaries. So so there's CF disk. There's also CHCPU, which changes the state of the CPU at that moment. Um, there's a CHMEM, which configures the memory. And by the way, I'm purposely not running these correctly because I don't want to like change the CPU or anything like that. But um, maybe I should do what is instead. Oh, dang it, that doesn't work. Did I not install the documentation for that? Yeah, but then that doesn't. Oh, come on. What's a good way to like print out the first line of a man file? I mean, because normally I would say, that's that'd use like what is or something like that. I guess like LexGrogger. No. Okay, whatever. Doesn't Catman do something like? No. Okay, I don't know what this does. Never mind. I mean, what CHMEM does that it lets you configure memory. I can talk more about that if you want. There's also CHM, which displays the OOM killer score. And what that does is that just tests for out of memory management. So it checks to see if the manager. I don't know why it's called score. I think it should be like status is a better word for it, but it just says whether or not the state of the memory at the time. So there's CHRT, which manipulates the attributes of a process, right? So you can change process. I could just do help. Yeah. So this changes the attributes of a process. There's column, which filters out reverse feed lines. So that's what that does. There's call CRT, which filters NROF output for terminals that lack some capabilities, such as overstriking and half-line. So pretty much what it does is that this terminal is like separated into columns. It's arranged in columns, but for terminals that don't have as advanced support, you can use column convert to like simplify things a bit for those displays. There's column remove, which filters out. Given columns, there's column, which formats a given file into multiple columns. What's a very, very cool function that is part of util Linux is the actual function Control-Alt-Del, right? So what this does is that, so as you might know on as you might know on Windows, what Control-Alt-Delete does is that it lets you select like the task manager or log out or something like that. In Linux, what Control-Alt-Delete does is that, well, it's Linux. I mean, it does whatever you want it to do, right? So what the Control-Alt-Delete command does is that it lets you set the behavior of Control-Alt-Delete. Right? So it lets you set what it does here. The two main things, just by reading the documentation, is that specifically you can set the Control-Alt-Delete key combination to either do a hard or a soft reset. There's also del part. So what del part does is that it lets you delete a partition. There's demessage, which prints out all the kernel boot messages. So you know how like when you boot into a Linux system, it'll like display those like it'll display those logs like if you do a verbose boot. So but what if you need to like access those messages after you like boot to like figure out what's going on? Well, that's what dmessage is. Oh, actually, oh yeah, I think you may even actually be able to see here when the Ethernet got connected there, or Ethernet got disconnected there. There's also eject, which ejects removable media. There's fallocate, which lets you allocate disk space to a file. There's FD format, which is something that I'm installing for. Yes, you are. You are looking at my OS right now. I'm going through all the parts of util Linux that I just made. So, what is it? Yeah, so there's FD format, which is something that I install for compatibility. But actually, what FD format is that it's a tool for formatting of floppy disks. So, whatever, you can format floppy disks with this command. And actually, it's not just for like fun. It's like I'm not expecting people to run this OS on systems with floppy disks. Although right now you totally could, since there's like so little on here. Um, what this is actually for is that certain tests later on, since this floppy disk thing is part of the Linux standard, so certain tests later on will look to make sure that this is here. So I'm just putting that there to make people happy. So there's fdisk, which lets you manipulate the partition table of a given device, right? So you can do like fdisk /dev/ like this, right? And then you can, what is it, like p is print? Yeah. So here it is. So here you can like use this to look at the partition tables for devices and things like that. I don't want to touch anything in here because that would be very bad, but that's just what that does. There's also f in core, which lets you count pages of file contents in core. So if you do like f in core, and then what's a file here? Okay, mkfs. So it lets you just count how many blocks it has. There's find fs, which is find a file system by label or UUID. There's find mount, which is a command line interface. So there's find mount, which is a command line interface to the libmount library for working with mount info, fstab, and mtab files. So what find mount is going to be important for is that, again, all of these commands, you may not have heard of these before, right? And you may be saying like, wait, what's the difference between something like find mount and mount or something, right? And it's weird, like what are the point of these tools? I know other tools that do like similar things, right? But probably better. Those tools that you're thinking of are probably running all the things that I've just been talking about in the background. Like, so for example, find mount, right? What that does is that it's a command line interface to the libmount library to work with fstab and stuff like this. This command is run on every single boot, like actually in the bootloader stage, in order to figure out which file system to load. So find mount is a very important command that, as a Linux consumer and even a Linux developer, you have no need to use, because again, I'm making the core parts of the operating system that you don't have to worry about. But these things are very important. So when I start setting up the kernel and start getting ready to boot into it, I'm going to be manually running and setting up these. I'll be writing programs that have all of the util Linux commands that I've just been talking about in there. So there's also flock, which requires a file lock and then executes a command with the lock held. There's also fsck, which is used to check and optionally repair file systems. There's a bunch of different like fsck versions. There's fsfreeze, which calls the fi freeze system call on kernel driver operations. There's fstrim, which discards unused blocks on a mounted file system. Let's see. There's get opt, which parses options in the given command line. So this is used probably if you've like written shell scripts a lot, or hex dump is something that I just installed that's important. Can I use this in interactive mode? No, I guess not. Okay. There it is. Okay, so what hex dump is that normally you run hex dump on a file, right? You like put a file in there and then it'll print out the hex versions of it. But I can also just like, it can also just read from standard input. Hi there, how is it going? My name is. So that's kind of cool. There's also HW clock. That should not have happened. Because I know I haven't made the kernel yet, but this should still be working with the current kernel. So it's able to get the system time. Yeah, what? So it's able to get the system time, but then it's throwing an error. So that's confusing. Whatever. So there's I386, which is a symlink to set arch, which really shouldn't be because I386 is an arch. But anyways, I386. This is a symlink to set arch. Command not on this motherfucker. Oh no, I'm so sorry. I'm so sorry. I'm on ARM, so that wouldn't be the case. There's IO nice, which if you use Linux, you might know about like nice, where you can set like the priority of programs. So you can do that. You can create IPC resources. You can use IPCRM, which removes interprocess communication resource. A bunch of stuff with interprocess communication is what this looks like. Kill, the kill command to quit programs. That's kind of important. Last, we'll show you login attempts and all this. This is not working yet since I haven't actually set up a usable user system. Nice. Do you know ARM assembly? Which sort of ARM? There's actually a couple different sorts. So for this, I've had to do, as I told you, like for assemblers and stuff like that, I've had to use ARM 7L assembly. Have I? Yeah. Not like I had not done any real assembly though until this project. So let's see. But I'm gonna have to get into more. I've had to do again some at the beginning when I was making the assembler. I'm gonna have to do more later when it comes to the kernel. Are you familiar with x86 assembly? That's like I haven't used that at all in this project. That's what I was saying, like pretty much not at all before this project. So that pretty much isn't absolutely not all. I've done a bit. The other one is at x86 64. So I've done like 64-bit, but it's all. See, actually, when you say x86, is that's actually a family of like CPUs and not an actual assembler or like assembly language. There's different versions of that. So normally when people say like x86, they're talking about i386, I believe, and then and i386 I think is the architecture language I was using. Or is it the other way around? No, x86 is the instruction set, I believe. 8086 assembly. I could have it backwards. So then yeah, wait. I'm gonna look this up. Oh, you are totally right. Yes. Okay, so i386 is the specific family of CPUs, and then x86 is the language. Okay. Yes, my bad. Because you can write x86 assembly and set your instruction set to 486 if you want. Okay. Because you can write x86 assembly and set your instruction set. I see. Because you can write x86 assembly and set your instruction set. to 486 if you want. Didn't you just say above though that x86 is the instruction set? I'm not trying to like I'm actually confused, and it would be cool. And don't forget to tell me to change this back later. But you said x86 is the instruction set. And then you said you can write x86 assembly and then set your instruction set to 486. Or 380, whatever you meant to say. I think you might have meant to say 386. But so as I'm actually trying to learn, right? And this is actually great because this is what I wanted to get from this. Which one is the instruction set? Is it x86 or is it 386? So it's kind of extra-ish. It exists in all. It's not like using classes in C++ and saying it's C, even with a C++. So now is it C or C++? No, I get that. But when you said this, because you can write x86 assembly, does that mean like when you're writing like the opcodes and stuff like that, you can write the opcodes in whatever way you want, and then when you assemble it, you can like set like the assembler like backend to be like i486. So it's like i386. That's the actual processors, right? So that would be like the backend for the assembler, and then x86 assembly then would be like that sort of front end. So you can write. So if you have an instruction set, right? Like if you have an i386 CPU, you could write multiple different kinds of assembly for that single instruction set. For that, you can write multiple different kinds of x86 assembly for the i386 processor, right? Because is that what you're saying? I'm sort of confused. It's not like using classes in C++ and saying it's even with a C++ compiler. So now, yes, I get what you're saying when you say that. I think because you're saying like once you compile it and you look at the ones and zeros, it's like you can't tell it. Well, actually, you probably could if you decompiled it because it may compile it differently. But I get what you're saying. That that it loses its individual, like the structure of the source code itself gets lost when you compile it. You can write. I'm just actually. So I've coded things in ASM using MASM. At the top of your program, you can write .386. Yeah. x86 is like the macro level instruction set. No, I get that. So that's what I was gonna say. So so you can't. That's sort of what I was saying. How there's like multiple like back ends to it, and also multiple front ends. So like you can. So if you're making like in oh, what was I saying? Okay, I know, but it seems like you may know in some. It seems like you may know more than I do, so I'm trying to learn. So x86 is like the macro level instructions. So it's like if you're writing C code, you can write a C program and you can compile that exact same C program on a Mac or a PC, right? And the thing is though, is that even though that source code is portable, right? Because depending on like what functions you use, but let's just say it's a function that is portable, right? You can run that on multiple machines, right? But the thing is that the actual ones and zeros that it compiles into, right? Although I've learned that that's not even, because with all the linking, but keeping linking out of the picture, right? The stuff that those ones and zeros probably won't be portable across those different CPUs. So there's also a lower level equivalent of that where if you have, and you're saying the specific processor would be like i386. So if you have an i386, well, actually, maybe this isn't even the best. Okay, so well, that's one analogy. Is the C++ on like multiple different on different operating systems. But another thing is that you can also have different. But if you're trying to write code, that runs on Linux, there's multiple different languages you can use, right? So you can use C code, or you can use C++ code, or you can use, okay, let's just say, so you have C and you have Rust, right? So you can either, so C and Rust will both compile down to the ones and zeros, right? But the thing is that it's just a different, so you could conceivably even write a C and Rust program that compiles into the same ones and zeros, but you just used a different language to, you just use a different language to say that you wanted those ones and zeros. So similar to that, if you have an i386 CPU, right, there are different assembly names you can use for things to write for that CPU. Like, for example, x86 is one language that runs on i386 processors. But there could be other things that will also run on those. But something that's not compatible, right, is that if you have like ARM, like ARM7, right? If you have an like ARM7L or whatever. So if you have an ARM7L CP, so if you have an ARM, yeah, so if you have ARM7L assembly code, right, that you can't assemble that into the ones and zeros that you need. And then in the same sense, you can't write x86 code for ARM. Am I making any sense right now? Like, am I saying anything that's right? If a brand new instruction set added to it, you're not going to program with it, because no CPU can use it. It's almost like that, but with assembly, there's a physical filter being the CPU itself. An old CPU cannot run. No, I get what an instruction set is, right? I mean, instruction set are things like add and move and jump. But so that makes sense to me. It's whatever the guy who made the compiler assembler. Yeah, I know. Sorry for for going so in depth. I get what you're saying there. I know what an instruction set is. I was just confused about the difference between x86 and i386. That's what this is all about. And what you're saying the difference is that x86 is a language you can use to write 386 code. I mean, it is sort of a much lower level analogy to the, yeah, exactly, a much lower level analogy to the C++ thing I was talking about. Oh wait, no, that's actually different than I was thinking. Okay, so wait, when you say x86 is like C++, you're saying like x86 is like the first version of C++, and i386 is the successor, or you're saying x86 is in general like the standard, like whatever the standard people say it is, and then i386 is like an actual like implementation of that. Okay, it's like a macro thing. Yeah. People understand what you mean when you say C++. No one's gonna go like. Okay. You still know what it looks like in general. Oh, okay. Okay, so x86 is a family of languages, or a family of instruction sets, including i386. So i386 is one instruction set, part of the family of i386. So you have different. I mean, part in x86. So x86. Oh, okay, good. Yeah, maybe I just googled it. That answers my question. Thank you. So x86 is a family of instruction sets and then I386 is an instruction set. I can make it super like matrixy if I. Yeah, so okay. So I think I get it now. x86 is a family of instruction sets, and then I gotta mute this volume. x86 is a family of instruction sets, and then I386 is one of those. That I'll just stick with that. Is it though? I actually thought those were similar. I mean, x86 underscore 64, isn't that just the isn't that just the 64-bit version though? Yeah. You know what? Why don't I? But then I won't be able to see what you're saying. But if I look up x86, see, maybe you should be streaming if you're doing all this googling. What is x80? Let me go to Wikipedia. Simple English. That's what I'm talking about. No, just kidding. Okay, so x86 is a family of instruction set architectures. Well, yeah. So clearly, if you can use so x86 works for 16-bit stuff, 32-bit stuff, and 64-bit, right? Yeah, yeah. 16, 32, and 64. But since x86, but now I'm learning. See, now I'm applying what you said. But what you're saying is that x86 is a family of things, right? So what x86 64 is that is part of that family, right? In fact, it's probably like a subfamily, right? Because I'm guessing x86 underscore 64 is another family of instruction sets, right? Because you can have different Intel 64-bit CPUs with different instruction sets. So x86 64 is another family of instruction sets, all in this family of x86. So we got some genealogy going on here, is I believe the moral of the story. But then 8080. So I think that answers it. All right. And then what have you been saying? Basically, yeah. I mean, I'm not 100% sure the deals, but what makes 64-bit is the register size. Yes, because you can use, for example, move with a 16-bit register, like AL instead of EAX, I believe so. I mean, I've written the same code on 64-bit and it works. It's just registers that are different. Yeah, that's true. Is that well? Because that is an actual physical difference. That's what I've been learning about on this because so this operating system that I'm making at first is going to be a 32-bit operating system, and then I'm going to transition and make it 64-bit because the Raspberry Pi 4B actually has a 64-bit CPU, but by default it's turned off. Like Raspbian, the operating system that comes with it, and all the tools and the kernel that comes with the Raspberry Pi, it's all 32-bit. So I figured it'd be easier if I first made a 32-bit OS and then made it 64-bit. But that's true. But one of the things is that, and one of the reasons that people were complaining that the Raspberry Pi 4 has a 64-bit CPU but only a 32-bit kernel is that a lot of the registers are go unused because CPUs that can work in both 32-bit and 64-bit modes, they actually have 32-bit registers and 64-bit registers on them. Well, there's some stuff going on the stream, right? How's that happening? You see that? Why is that going on? Like the physical registers. What is that? When you say you're working in 32-bit mode, what does that mean? Yeah, so exactly, pretty much. So even though I have a 64-bit CPU, oh, so maybe that's what it is. Okay, because I've been reading about about that. And all I know is that, okay, so wait, AL is the lower part. Okay, hang on. What does that mean? Um, what I have read is that processors that can do like 32-bit and 64-bit, like can run whole operating systems in either. The CPU has a physical, well, I don't know how like physical it is, but there is a flag in there in the CPU that's flipped, depending on if the kernel is running in 64-bit mode or 32-bit mode, and that things will act differently depending on what mode it's in. I don't know if that's, and one of the things that I read, I'm really hoping you can correct me, is that, so one of the things that I read is that one of the things that gets switched when you switch the mode is the registers that are available to you. That could be untrue. In my project back when I was on 32-bit, the CPU actually starts in 16-bit mode, called real mode. Actually, what are you saying? Okay, so RAX and EAX are not different physical registers. EAX is the lower part of RAX and AL. Is AL like a 16-bit thing? Like, is AL the first like 16 bits of EAX? Is that what you meant? Or the first 16 bits of EAS? Is that what you're saying? In my project back when I was in 32-bit mode, the CPU actually starts in a 16-bit mode called real mode. Oh, AX is 16-bit, AL is lower. Okay. You have to actually tell the CPU to go into protected mode, 32 bits. Yes, so that's what I've been reading about. This is done usually in the bootloader, I believe. Yeah, so that's what I'm going to be working with in a little bit. I only ever did OSF on a 32-bit CPU, so I missed one AX. Oh, I see. So you're right. It's not totally different registers. It's just when you switch the CPU mode, it's only looking at those registers. Okay. So it's possible I was wrong, but I'm also doing it on ARM. It could be different on ARM because I'm not doing this on Intel. But what I read, oh shoot, wait, what? I did not mean to do that. No, wait. Um, uh-oh. Oh shoot, what was your name? Blunt S. I hope that worked. Okay. Sorry about that. I just like clicking around and selecting text and stuff. Uh-oh, I hope you're still there and you didn't like rage quit out of the channel. Okay, sorry about that. Chronology. I think I'm starting to understand. Because I'm also looking at sources right now. if you scroll down, you'll see LGDT, which loads a global desk table, GDT. Which loads the global description table. Then the CRO register gets modified. Move EAX. Okay, enter 32. And then if you scroll down, you'll see LGDT, then the CRO register. So is the CRO register what whole is that on here? No. Okay. Anyways. So is this the register that like controls whether or not like which mode it's operating in? It's either protected or real mode. 0 protected mode enable if 1. System is in protect else. Okay, what does protected mode mean? You said that it needs to be in protected mode to run like the 32-bit? All right. Let's see, protected mode, also called what? Okay, so it's 20 bits of memory space. That is not a lot of memory space. 1 megabyte of addressable memory. And unlimited direct software access. Okay, but then protected mode, it uses virtual addressing, which means that okay, yeah, so it includes virtual memory. That's the difference. That protected mode lets you address virtual memory. Ah, cool. Looks like it's for backwards compatibility until you load up the CPU. No, I think it's the other way around. I think real mode is for backwards compatibility until the CPU is unless I'm like because it's saying here that real mode only allows like whatever, like 1 megabyte of memory. And then it doesn't have any sort of virtual memory, right? It's just direct access to the addressable memory IO addressers and peripheral hardware. So I think, and it says here that the x86 start in CPU mode when and it says here that CPU mode, that real mode is just for backwards compatibility. Okay. Well, anyways, not to make the same mistake as before. Woo! All right, so what other things that I just installed? So, cool. And then you have logger that enters the given message into the system log. So if you do logger, you can put messages into system log. There. You can use look, displays lines up again with the given string. What? How does that work? So if I do look more int. Oh, look int. Okay, I don't get what that does actually. LO setup controls loopback devices. LS bulk. LS CPU prints CPU architecture information. Oh, so now I have see, as you can see, I'm installing a lot of tools that'll be used for that. Like, fun fact is that even though it says the architecture of the CPU is ARM v7L, this is because it's simulating a 32-bit CPU, and this is actually ARM 8. The CPU in here is an ARM 8 CPU, but it's running in ARM v7 backwards compatibility mode. And then let's see, LS IPC. The reason that I'm using only 32 bits right now is because the Raspberry Pi, by default, like Raspbian, the OS and all of that stuff, uses everything on the Raspberry Pi in terms of software is 32 bits. And the reason for that is to keep backwards compatibility with all their products, because most of their products are 32-bit, and only recently have they been 64-bit. And I guess the people over at the Raspberry Pi Foundation are lazy and don't want to have to maintain two different like kernels and operating systems, and not just the kernels, but also like the web browser and all that stuff. I guess they don't want to maintain two versions of that. So instead, they just put a 32-bit operating system and 32-bit apps and 32-bit everything on the Raspberry Pi. And then, so for me, when I'm doing this at first, to make this a bit sort of like easier, is that I am going to be writing this stuff. My operating system will be 32-bit at first, because it will be easier to debug if things are going wrong, and it'll be easier to figure out what the problem is if I keep things similar to the Raspbian kernel. And then once I do that and I find all the bugs and I fix all the bugs, and once I fix all the bugs that I know that are caused by me and not a different kernel version, then I'm going to go and switch it to 64-bit. So to answer the question, the reason that I'm using 32 bits is because that's what it is. That's what it is right now. So it'll be easier to debug in that mode. And once I fix the bugs in that mode, I will switch it to 64 bits and then fix all the stuff in that mode. So LSIPC, this is just listing all like the pipes and stuff like that. Let's see, LS locks will list all the system locks. Cool. There's LS logins. Oh, that is cool. There's LS memory. The system does not support memory blocks. I will get to that. List all the namespaces. Cool. There's mcookie. Oh, look at that. Generates a cookie. That's cool. There's message that controls whether other users can send messages to the current user's terminal. Nice. There's mkfs, which is to make file systems. Again, this stuff is going to be very important later. There's a make swap, which you can use to give, which will initialize like a device, or you can specify either like a partition or a file to use a swap space. There's like the more command that you probably know about. There's mount to mount files. There's mount point, which is a Boolean, which will return whether or not. So if you do like mount point, and then a directory like slash, it will say that because it'll say whether or not it's a mount point. But then if I do mount like dot, it's not a mount point. If you do name I, it shows the symbolic links in the given path name. But like, okay, anyways, there's ns enter, which runs a program with namespaces of other processes, which is very cool. This is, again, you may not have used ns enter specifically very much, but it's used in a lot of debugging tools like strace or whatever, dtrace, whatever they call it nowadays. There's partx, which is used to inform the kernel about the presence and the numbering of on-disk partitions. There's pivot root, which marks the given file system the new root file system of the current process. So it's not the same as chroot, but pivot root is actually a part of the chroot process. There's PR limit, which lets you get and set a process's resource limit. So if you do like PR limit, this, it tells you, you know, all the limits. And and as you can see here, I have not, most of the again, $$ is bash, so bash doesn't have a lot of limits set on the processes. Raw will bind a Linux raw character device to a block device. There's a read profile, which this will tell you a bunch of the kernel profiling information. So again, I haven't set up this stuff yet. Again, not all of the stuff works because in the next, I am going to, over the next few days, be doing a lot of kernel stuff. So as you can see, a lot of the kernel commands that I do aren't actually working because they shouldn't yet. So there's a rename, which renames the given files or replacing a given string with another. There's renice, which lets you set the process priority. So renice lets you set process priority. There's rev, which reverses the lines of a given file. So if you say that, you know, so you can say echo 130, type that into rev, and you can see that it reverses everything in there. So that's kind of cool. Actually, what's interesting is that, wait, I'm being silly right now, but is that reversing it in a logical way? Yeah, it is. It is. Okay, never mind. So rkfill allows you to enable and disable wireless devices. RTC wake is used to enter a system sleep state until a specified wake up time, which is cool. There's script, which makes a type script of a terminal session. So you can type script and then do some stuff in the terminal, hi, whatever, and then exit. And then you can see here that, oh, I should have done this. Oh, there it is. TypeScript. You can see that file right there, this TypeScript file. And with this, and then I can use TypeScript. I'm trying to actually remember. Or I'm sorry. Oh yeah. So then you can use script replay, and then, oh motherfucker, timing file. Okay, hang on. I mean, so if I do script T, and then I do ls or something, right, and then I exit it, then if I do script replay, oh, son of a motherfucker. I actually had to do this stuff earlier before I installed it on here. I was working with script on the host operating system because I needed to automate some unit testing, and I'm bad at unit testing, so I use script. Okay, so it's script file name. Oh, script started. File is TypeScript. No, I think this started recording. So then if I do like exit, it'll save the file in a name called TypeScript, but I'm trying to replay it. And there is a thing called script replay, right? And then script replay, and then like whatever it is. So then TypeScript, but then it's saying that there's not timing information, which makes sense because if you look at man script, you can see here that it doesn't come with timing information by default. Yeah, so there it's like T, that T option. But I don't think you need to say that. Like, I think you can replay without timing information. It just does everything at once. But I'm trying to remember how to do that because that's what I did earlier. Anyways, no. Okay, so I could do that, but there's also a way to just make it not ask for anything at all. But yeah, I could do that. So I could do script T timing, and then yeah. So now I can do ls. Oh wait, that I don't think that works. Oh Jesus. Oh yeah. To do it the way you did it, so script timing equals time. All right, so now I can do ls cd dot exit. Now I can do script replay, and then timing is equal to, what the fuck did I call it? Timing, I hope. And then motherfucker. Oh, I called it time. Oh, there we go. Oh, you can't even tell, but I'm not typing right now. So that's kind of cool. Okay, I thought there was a way to do that without having to go. Whatever. Okay, there's also the set arch command, which changes reported architecture in a new program environment and sets personality flags. There's the set SID, which you might be familiar with, like the set UID. This is similar. This runs the given program in a new session. There's also set term, which allows you to set terminal attributes. There's sfdisk, which lets you manage partitions. There's su login, which allows root to log in. Su login. So there is a couple of other things. So there's like swap label, which allows you to change swap area UUID. How long have I been using Linux? That's a good question. Depends on what you mean by Linux. If by Linux you mean Linux, then probably a few years now, like maybe like 2 years. But then in the last year, I got like really into it. Although looking at this now, it seems like I don't know anything. But if by Linux you mean Unix stuff in general, I've been using that for like a long time. Like on my Mac, I've been using a lot. Like I've been using the terminal on there for a very long time now. I used to be very big into like jailbreaking. So, under the hood of like iOS and iPadOS, like my iPad that I have over there, is also another like like Bash terminal and all that stuff. Like Bash is actually on iOS if you like hack it, so you don't even need to like install Bash separately. So I've been using like if by Linux you mean Linux, I've been using it for 2 years like a decent amount, and then like 1 year like a hella amount. But if by Linux you mean like Bash or ZSH or something like that, then like a very like 8 years maybe. Yeah, although definitely from what it seems like on this stream now, it seems like I've been using Linux for 5 minutes. So there's swap off, which this just disables like swapping. There's switch root. So there's switch root, which switches to another file system as the root of the mount tree. Again, similar to chroot. There's also tailf, which tracks the growth of a log file, and it displays the last 10 logs of a log file, and then continuously displays any new entries in the log file as they're created, which is cool. There's ul, which is a filter for translating underscores into escape sequences. This is just like a terminal use of life thing. There's umount to unmount things. There's uname26, which is symbolic link to setarch again. There's unshare, which runs a program with namespaces unshared from the parent. There's utmp dump, which displays the contents. Oh, utmp dump. So, oh wait, I thought that would have done. Anyways, what that does is that it displays the contents of a given like login file. But UUID is a daemon used by the UUID library. There's UUID gen, which generates UUIDs. There's UUID parse. There's wall, which is cool. This lets you display the contents of a file or send an output on all the terminals of all currently logged in users. So if I do like wall hi, then that should have printed everywhere, but whatever. Maybe it doesn't show by default. If I switch my terminal now to 1, no, that didn't work. Whatever. There is WDCTL, which shows the hardware watchdog status. There's where is, which reports the location of the binary source and man page for the given command. So it's like where is echo. This is a shell built in, so it's probably going to say that. Oh, it doesn't say that. There's wipefs, which wipes a file system signature from a device. There's x8664, which is another symlink to setarch. There's xramctl, which is a program to set up and control compressed RAM disk devices. And then there's a bunch of libraries that contains routines for device identification and partition tables, and pretty much all those things that I said before. So in summary, I just spent like the last hour going over all of the commands that I built from util Linux. Someone made another script replay without the timing. How long have you been using Linux? I had Arch Linux on my laptop like 5 years ago for a few months fun, and I used Linux Mint for my OS dev project because, man, trying to compile a clean binary in Windows is impossible. True. So I barely know much about Linux/Unix. So do you do most of your dev stuff on Windows? Because a lot of developers I know use either use Mac OS or Linux, and then definitely like the lower level programmers people are, the more likely they are to use Mac OS and Unix. And when they get to Mac OS or Linux, and then the lowest level people, they're definitely like using Linux. The only devs that I know, well, most of the devs that I know on Windows are like game developers. And if you're a game developer, then you're definitely on Windows. But except for that, most devs are probably using Linux or Mac OS. I started my journey in game hacking with C++ and assembly, and games are usually on Windows. Yeah, so there you go. So are you a Windows guy? Anyways, so that is util Linux. Obviously, like how Windows stores its dependencies and details. Oh, that's cool. Yeah. Yeah, I mean, like there are, Microsoft does employ like kernel developers. Like people don't normally think that because most kernel developers or like low level developers work on Linux, but like, Microsoft has a kernel too, and it works pretty well as well. So that's very cool that you know about Windows at such a low level. All right. Anyways, so let's get rid of that now that it's all installed. So the next step is that I'm going to install. So now that I have util-linux and the things that I've installed over the last couple weeks, I can install E2FS progs, which the E2FS progs package is I'll talk while doing this. So the E2FS progs package is a package containing the utilities for handling the EX2 file system and EX3 and EX4 journaling file systems. E2FS. So with the util-linux stuff, I can like go and do this now. So let's see. What kind of options do we have here? What do I want in my operating system? Actually, it looks like, well, hang on, don't speak too soon. I can probably just make this. No, I can't, actually. And did they say to make, okay, so first, they want me to make this in a subtree. They don't want me building this directly. All right, okay, we'll need these. Well, I actually need this, and then I think I want some other things too. Okay, that's cool. All right. So just to explain like what this is, so with the root prefix is like setting that to an empty string and then setting the bin dir to /bin. Certain programs like the E2FSCK program, they're considered essential programs. And then when, for example, /user isn't mounted, these programs still need to be available. So they belong in directories like /lib and /sbin. And if this option isn't passed to the configure here, the programs are installed into /user, which won't be good if we can't load that directory. And then enable ELF shlibs. These creates the shared library, which some programs in this package use. And then all of these disable things, this is just from building and installing the libuid and liblkid libraries, the UUID daemon, and the FSCK wrapper, as util-linux has better versions of these. So all the things that I disabled, you'll actually notice, if you look at the things I disabled here, these are things that I just went over from util-linux. So we don't need those. I read them from the config. Like I read the parameters there, or the possible options. And I mean, because I've had to do some of the stuff, like you get the hang of it. I mean, normally like I'd have to like have the configure file like in like a separate thing and then figure out what I need or what I don't need or what I want and don't want. I mean, again, some of the options are because like I have to do it that way or things will break. Other things like, oh, that's a cool thing. But although I didn't enable any cool things in this one. But there's a pattern to this. I'm also just like oh but maybe as you can see there see, maybe this is why I should have an eye on the manual there. Yeah. There's also like the Linux from scratch book, which like I guess also can help with like the options because they sort of like well at least they tell you like what things to keep in mind when looking for options. And like a lot of the stuff like I've used before, like the prefixes and the bender and that stuff. I have to change the. So actually, that's a good question. How do I remember these parameters? What the was that not? See, this is actually now I'm messing up here. See, maybe I maybe I do need to do that. So dot slash configure because whatever UUID. There's two D's. What? Oh, because it's a UUID daemon. Wow. Okay. UUID. But also, it's a good question. Like, how do I remember everything? One way that I go about like some things, like you've seen when I do the configuring, I put like the option dash dash prefix the dash that. Okay. So you've seen me do a lot like this. The reason that I have to do this is because if you use Linux or any of this, like if you've used Linux and used like app or whatever to install things, you'll know that the slash user directory, right? What's in the slash user directory, these are all of the things. What's located, okay, I'm sorry. Let me step back for a second. So all the things in slash user that aren't in like slash user slash local are for the operating system. So like you have like slash user slash bin slash bash, right? Everything in slash user are operating system. They come with the operating. You probably shouldn't even be modifying them. Like on the Mac, in order to edit anything in slash user, right? They actually lock it down by default. Like you can't edit anything in slash user, except for the slash user slash local folder, unless you like change a boot setting. So, however, slash user slash local, that directory, that's where the user puts their programs. So if you've ever used like, on Linux, if you use like apt-get install, or like Chrome or Firefox, right? Or if you use like pacman, what is it? Is it also pacman install, Firefox, right? That puts it in slash user slash local. So slash user slash local are where all the users' programs go. So on here in Linux, when I'm compiling something, right, by default, it puts things in slash user slash local, right? Because if you're compiling something as a user, then you're going to want to, then by default, it would put things where, the user created files are. Except in this case, what I want to compile is that I'm actually compiling things for the operating system, right? So I want to put those so I don't want to put things where the user's files go, which is normally where you want to install files that you're compiling. Instead, I want to put them in the slash user folder, which is for operating system things. So like that option, like the prefix is equal to user, right? I have to use that a lot because I want to override that. Like the bender equals slash bin, because normally for user stuff, you would install it in slash user slash local slash bin, right? So like the local thing there. But instead, since I'm actually since I want to since I'm doing something uncommon and I do actually want to install things where operating system files are because I'm making an operating system, I override that there. And then the root prefix is I'm setting this to be I'm setting that to be nothing. Again, that's because normally the root prefix means like if you want to install things in a certain directory, right? You could put the directory here that you want to install it to. So you can put here what you want, like what you want everything to be referenced relative to, And by default, I forget the path of this, but in this case, I actually want the root prefix to not have, I want it to just be slash, right? I want to install everything relative to slash because I'm making this as an operating system. And then these other options here, the rest of them, I just read them from the config, and again, we just went over all of the things that we just made in util Linux, right? And these things we just made, and they're better than what E2FS would try to make. So we're going to use our own instead. And then I saw this option, which I saw is like used by some of the packages here. So we need this library. So no, I don't have some genius level memory. Also, the Linux from scratch like book is also very good. Okay. Anyways, now that we're done with the configuring, I can go ahead and make this. Let's see how long it takes to make actually. All right, now for the moment of truth, we're going to check this to make sure everything works. It says here that the test will attempt to locate 256 megabytes of memory. Oh, that's fine. Again, all of this stuff, like, I've just memorized. Like, these actually are things that I've memorized because I've had to do them a lot. And there you said, if you notice, I didn't even have to read the documentation for, like, the check target because I've just done that. Been there, done that. So I have a question, Blunt. So, actually, hang on one second. So far, so good, right? Oh, sorry. The question I want to ask you. So the question I have, Blunt, is like, how did you find this channel? Like, you must just do you start at the bottom, like at the least viewed streamers, and just start going up, or was actually like nothing? Like you just started and went through. I don't know how many people are like streaming coding right now, but I'm guessing a bunch. Like, did you just scroll through like all of the people streaming coding right now until you got to me, or did you work from the bottom up? And if you did start from the top down, I am very flattered that none of those other people doing way more exciting stuff didn't excite you as much as, my title sounded. Really top down? So then what was it? Do you know what Luna Dev is or whatever? Luna Dev? I saw like hella people streaming that the other day, and I have no idea what it is. But is that like a game that everybody's working on, or? Look at that, 0 tests failed. That is what I'm talking about. Oh, it's a competition. Oh, like who can make the best game in 48 hours? Did you try it? Ludum Dare. So what make install does is that just installs the binaries, documentation, and shared libraries, and then install libs. What this does is that this installs the static libraries and header files. Oh snap! Okay, Koopa 1338. How's it going, man? Oh my gosh, we have 2 people in the chat at once. Oh my gosh, this is what Shroud feels like. The fact that he's just doing his thing, doing what he'd do anyways, and just getting all these people just watching him. That's oh man, it's choking me up a bit. All right. What I want to do is that I want to be able to remove a lot of the so I need to remove a lot of the debugging symbols from some of these libraries. Well, I don't have to, but what I'm going to do is that I want to later on be able, for specifically these, I want to remove the debugging symbols later on. So in order to do that, I'm going to make all of these writable. All right. Actually, I'm going to have to list everything here first. Okay. Oh, that's true. You know what? You're right. Shroud does not feel this good because he doesn't have blunt test nor Koopa 1338 in the chat. I don't know if you watch Shroud Koopa, but definitely without blunt test, his channel is just not the same. So Koopa, do you have like any programming experience, or have you ever used Linux before? So looking at what So Linux has a system-wide dir file, and what this does is that it like actually what dir does is that, but what dir does is that it sort of caches the names of all of the names and locations of a bunch of files, right? The thing is though, is that E2FS progs this it installs a zipped.info file, but it doesn't update the system-wide dir file. So I need to unzip. I don't know why it doesn't unzip it by default, but I gotta unzip this file. Ugh, and then update the system dir file using. So let's see. So if I just gunzip, and according to this, it installed it here. Okay, then you're currently on Linux and have a C++ step back. Oh, that's great. Okay. What kind of developer stuff do you do? Okay. And then it doesn't look like it installed the documentation. Whatever. Who needs documentation? So, now what I just compiled and installed comes with a bunch of programs. I'm just going to go over some of them. So, one of the things that it installed that we'll need for checking is like bad blocks, which this won't do anything now, but like it searches a device for bad blocks. There's shadder, which can change the attributes of files on an ex2 for file system. So on this file system, you can just use it to change file system attributes. There's debugfs, which is a file system debugger. Okay, the file system debugger. There's E2 E2 free frag, which is this reports on fragmentation information. There's E2 FSCK. This is like FSCK but for E2, so it'll like check to make sure that your file system and disk are okay. So yeah, there's those FSCK stuff. There's ls adder, which will list the attributes of a file. So here you can see all of the file system attributes for these, and you can and a couple of other things. The most important thing that this comes with isn't actually the front end commands; it's the libraries. So this comes with 4 libraries that will be very important when it comes to setting up our file system. So Koopa, what distro are you using? All right. So again, where we are right now in the just to remind everybody, we are getting ready to make the kernel, right? So we're setting up our environment. We are setting up our so we're setting up our brand new operating system so that it can make its own kernel. So that's cool. Using Arch for about 6 years now. You know, Koopa, a lot of people have asked me, like, why are you making your own operating system? Like, why go through all of that effort? It's like really hard. And the answer is, it's like, there's people, that are like, oh, what operating system do you use? And they're like, oh, I use Arch, by the way. We're like those Gen 2 folk, and you know those guys. So the reason that I wanted to take this on was that, I wanted to just, so that way whenever somebody says that and tries to like be superior to everybody else, oh, I use Arch, I can be like, yeah, all right, that's cute, because those Arch guys, they feel so great about themselves, because they understand Linux at such a fundamental level, such great productivity, so fast, bare metal. They're just better than everybody else. So I was like, I gotta one up these guys. So that's what I've been doing for the last like 60 hours now. Is just trying to do something to, you know, yeah. See, you guys know what I'm saying, you know, like, dude, Arch, you might as well be on a Mac. That's all I'm saying. No, I'm just kidding. I'm just kidding. This is actually like, I think it's really cool that and obviously Arch is like, you don't actually, in order to be like very productive and awesome with like Linux, you obviously don't need to make your own operating system. But I thought this would be like a fun project. But yeah, Arch is cool as a Windows user into program. I can relate to that. Yeah. All right. So the next thing that we're going to be using on our step to making a kernel is syslogd, which the syslogd package. So the syslogd package contains programs for logging system messages, such as those given by the kernel when unusual things happen. Yeah, obviously it's for education. Like, I'm going to work on this a lot and try to make it as good as I can. but I suspect that I will not be competing with Canonical or Red Hat anytime soon. Because I have a feeling that even though I'm going to give this, I'm going to try to make it my own and make it awesome, I don't think it's going to be better than Ubuntu or Manjaro. So, so at so when all is said and done, and I've made it as best as I can, I think what I will have mostly gotten out of it is the education and knowledge. Ever heard of Temple OS? Oh my gosh. Have I ever heard of Temple OS? Well, if you guys would search from the bottom up on the um, on the science and technology thing, you will see that there is a 24-hour live like continual thing of what's his name? Terry Davis's yeah, Temple OS archive. Yeah. So I'll raid him after this. Yeah, see, like, could you imagine like what Terry would think of you if you were like, oh, what operate, oh, I use like Gen 2. It's like Gen 2. Like that's the he would if you said you use Gen 2, he would think that that's like the most like least user interactive, most high level abstract thing in the world. So Terry Davis is the man for anybody, Like I mean all the Arch and Gen 2 people, they love him. I love him. Exactly. I know. I'm joking about the elitist thing. I mean, you know, I don't even really know what I'm doing with this. Yeah, exactly. No, definitely. Everybody should use what works. Like somebody came in a few days ago and they were asking, well, what Linux distribute. They said that they had never used Linux before, but they wanted to get into programming and wanted to know what Linux distro and what this person in the chat was trying to tell this person that they're pushing them super hard to use Arch or Manjaro, right? Manjaro may be a little bit different, but it's still like those two. And and again, this was somebody that didn't use Linux but wanted to learn about Linux and like use the terminal and stuff like that. Um, and because again, they never used Linux before. They just wanted to join. They just wanted so they were hoping to join the channel, right, to learn some stuff about Linux, and they wanted to know which Linux distribution to get so they could so they could learn more about Linux. And again, this guy in the chat was really pushing Arch, and I was saying that TBH, which would probably upset a lot of people in the chat. Said if you're somebody that's used Mac or Windows their whole life, and you want to learn about to get started with Linux, I said this may make some people upset, but try Ubuntu. Ubuntu is very Ubuntu is great for starters into Linux. It's very user friendly, but there's still the terminal there, Truth is, almost everything that you could do on Arch, you can do in Debian. I mean, like you can change your desktop environment, you can recompile your kernel or whatever you want, right? But it's a friendlier gateway drug than Arch, you know? I mean, definitely like once you've used Ubuntu for a while and you get the hang of it and you're learning how Linux works and the terminal and shell and all that, then I would actually encourage if somebody came to me like, hey, I've been using Ubuntu for a few years, you know, and I want to learn more about Linux, what do? I would say, oh, why don't you try switching to Manjaro or Arch? I would probably say Arch. Oh, why don't you try Arch if you've been using Ubuntu for a few years? But if I'm just trying to grab somebody out of the Windows world and put them in the Linux world, like I think Mint's also good. Mint's a good in between. Ubuntu's super bloated, but not compared to like Windows or Mac, you know? So that's what I'm saying. It's like a good gateway, So fine, maybe if they've been using Ubuntu for a while and they say, oh, what should I do to learn more about Linux? Maybe instead I would say Mint or Mint, Manjaro, Arch. Those are all good things, but just like as the very first. How did I get started on this? Oh shoot! Somebody else joined the chat. Memorious IT. Hey, dude, what's up? How's it going? Sorry I didn't see you at first. Um, yeah, how's it going? You're like one of my first viewers ever. I've only been streaming for a little while, so how's it going? Do you have any programming experience before? Have you ever used Linux? Yeah, exactly. I mean, distros really are. Yeah, I would say that's right. I mean, what is a distro except for a bunch of like a kernel and a bunch of programs, you know? But even the kernel is kind of overrated because most Linux kernels you can't sort of like swap them out, you know? Like you can probably run a like Arch user space over like on a Debian kernel, probably, right? I don't know if you could run Ubuntu over like the Arch kernel. I don't know if everything there, but it probably is. So I think you're right. A lot of people don't really get what isn't a distro just like Arch plus programs. Putting that on an ISO. Blunt test, you're pretty much right. Although I would say distro is like a kernel plus Arch plus programs. Yeah. Although doesn't Arch come with things like Bash? Like I know Arch doesn't come with like a desktop environment, but I think it comes with like Bash and things like that. So there is some user space stuff that Bash has with package management. Well, package management you could think of that as just another program, right? But you're right. Oh my gosh, wait, a new. Oh, this is crazy. Yo, I'm blowing up right now. This is definitely how Summit 1G feels. Distros, how's it going, John's Udar? Uh, yeah, so I'm trying to make my operating system right here. Have you ever used like do you have any programming experience or have you ever used Linux? Well, it seems like you have used Linux because you know about package management. So Arch is 100, but like without going too far, it's basic. Yeah, exactly. I think yeah, I agree with you, Blunt. Oh snap! Okay, so this is like my third day ever streaming, and I've never had more than like more simultaneous viewers than I think right now. But and I just started streaming, and I hate to already shill, but if you guys wanted to, um, like if you guys wanted to follow, that would be like a super like cool thing, and because I mean I like hanging out with you guys, and I think it would be cool if because everybody in my chat's like really knowledgeable, so I think it would be, and everybody has like different experiences. Selfishly, I am hoping, John, you stick around because that would be um, yeah, I may need you at some point. I will definitely need you at many points. And I don't know if you guys are following. I set it up so that like an animation will play if somebody follows. Has anybody seen that animation yet? I don't know if nobody's followed yet today or if it's just not working. Actually, I think I saw that once today, but I don't know. Oh, there we go. Look at that. Thank you, Koopa, so much. Again, I really, really appreciate that. Like, I just started doing this a few days ago. And obviously, I'm not at ninja level yet, you know? Like, I still gotta, like, some things that I notice that I do really badly is that I'm really bad at multitasking. Like, I have this terrible habit of I'll talk to the chat for like 20 minutes without doing anything, right? And then when I'm done talking to the chat, like the thing that I was about to do before I started talking to chat would have been like to compile something. So it's like I talk to chat for like 20 minutes, right? I'm done talking to them, and then it's like I compile, right? I press compile, and then it's like, and the compilation takes like 10 minutes, and I have like nothing to say. So it's like I gotta get better at like, you know, at trying to, I gotta do some better multi-threading. You know what I'm saying? While I'm what is it? While I'm blocked on compilation, you know, while I'm blocked on this compilation thing, I can move to some IO with the chat and do that instead. If you catch my drift. I haven't seen it when I followed. Well, it just played then. So I don't know why. Yeah, that's weird, Blunt. I don't know if John followed. Yeah, my scheduling. Yeah, yeah, right now it's sort of first come, first serve. It's whatever I'm thinking of. Actually, no, because I get interrupted a bunch. It's not first come, first serve. It's probably like the worst algorithm because it's actually like whatever thing that I see that takes the longest. If I see something and it'll take longer, I immediately like I'll block there and then I'll swap and then I'll do a context switch to the longer thing. So if I'm doing something short and something long comes up, I will actually context switch to the longer thing for no reason. So I gotta get better. Thanks, John. All right. Anyways, thanks so much, John. Again, that means a lot to me. Like, I got to get a lot better with the streaming stuff. Got to get better at explaining. I got to figure out more what the channel is because I know I'm doing Linux from scratch. But what I also hope to get from this is to be able to learn more about Linux from the chat because everybody, or just about computers, everybody in the chat's like very knowledgeable. And then I hope to teach you guys some stuff, and I hope to learn a lot too. Anyways, okay, so here I am. And also, so John, what kind of Linux from scratch did you do? Because unfortunately, I have to do a lot of improvisation because I'm trying to do this on ARM, and there is like a cross Linux from scratch thing, but the documentation on that's like very shoddy, in my opinion. So I've had to do like, um, so on ARM, because I'm trying to do this like on ARM for ARM. So it's been like a very different process, and the book has been like useful in some parts, and like really not useful in others. Yeah, well, you don't need to be motivated. I mean, if you have like x86 already that you can do it on. All right. Anyways, um, so speaking of documentation, syskloggd um, apparently there's a bug that um that causes a segmentation fault under some conditions in kloggd. So in order to fix that, I need to change. Okay. I think this should fix it. Oh, that was easy. Oh, that's okay. That's super easy. All right, but now I got to do some configuration. So what syslog D is that I said this a bit earlier, but it's used for logging system messages, especially those like that are given by the kernel when like bad things happen. What does sed do? Great question. So sed is the stream editor, which doesn't make any sense. Pretty much what sed does is that it lets you edit text, but not like how like Word lets you edit text. What it does is that if you give it a piece of text, right, it will be able to like edit things. So here, let me do an example. So this is good. So what's a good example of? Okay, so if I go and I have like a file, right? So let me vim file.txt, right? So I have hello there, how are you today? 1, 2, 3, 1. I'm making this up as I go along, so this may not make any sense. Okay, so what I can do is that, so here so again, this is what my file looks like. What I can do, I'll answer that in 1 second. What keyboarding keys? Good question. Okay, so so what I can do is, if I do this, so what the I flag does is that this will edit the file. So maybe I shouldn't edit the file. How do I make it not? I think O. This may not work, but anyways. So what I can do here is that first. Okay, so what's important? This is what's important. So I can do sed, right, which calls this command, and then I can say s. So everything inside the quotes will be the argument. So s means substitute, right? So I'm going to be substituting things. So what I could do is that I could substitute wherever it says 1, right? Substitute 1 with, I don't know, with but, okay? Right? So now with this, and then I can say what file it is. So this is file.txt. So as you can see, here's the original file, right? And then here I did 1/but, and then that replaced all the ones with buts. You can do a lot other things with NOP, just the first one. Without modifiers, what? Oh, you need G? Oh, yeah, you're right. Okay. I didn't even notice that that wasn't there, but yeah, you need, otherwise it'll just do the first one. Yeah, I was reading the chat. Good call. I was saying, oh, look, it worked. And then I didn't actually, I just saw the first but. But yeah, you need G, otherwise, that way it'll do it everywhere. So there's different things you can do. Like you can do, like, so instead you could do like, what is it? Like you can do D, which I think will delete all of them, right? Oh, fuck. Oh, no, okay, because we're doing S. But like if you didn't have that, then you could do D, I think, or there's a bunch of different so wait, what are the, yeah, so G does global, and then I'm trying to remember if the other things. Oh, you can do like I think you can do like this, and then like I know, like you can specify like line numbers, I think, if you do like, so if you do like line number 1 and then replace so I think if you do 1, like replace H with 7 or whatever, I think what this does is that will, yeah, so that'll only do it on the first line. I said it can do a lot more than like substitute, but that's pretty much all I use it for. You can, there's also other things, like you can do like D, which will like delete things. You can do A, which will append stuff and not replace. Although you can also append stuff by doing like capture groups. That's where things like sed become very powerful. Where sed becomes very powerful is the fact that you can, well, actually, okay, sed becomes powerful in just 2 places. Is that sed, you can make it not just replace like words, you can make it replace patterns using something called regular expressions, which is very cool. Everything ed can do. Oh, that's true, but I mean ed's like, that's old. Okay. Anyways. Actually, you can also just do man sed, yeah, so stream editor. So here's a bunch of the options here. So here A, yeah, so A is append, and then insert text. Yeah, a lot of cool stuff. Okay, now this is just yeah, sorry for rambling a bit. All right, now let's go ahead and make this. Do I have to, oh, sorry. Oh, wait, no, I already made it, right? Didn't I already? I'm losing where I was. Yeah, I already installed it. Okay. Oh yeah, I have to. Okay, so now I have to configure this. So the configuration is like an etsy syslog.conf. By the way, having to do this like operating system without Vim was like really tough. And when I was finally had all the libraries I needed to compile Vim, that was very nice. Okay, okay. See, now for this, I am looking at like an example file because I need to know how this works, and I don't know all this stuff by heart. Yeah, so this is actually one of the areas. So maybe I could talk about this a bit, but this is an area that I don't know that much about because this is all. So what syslog, from what I know, at least like the front end for it has mostly been replaced in modern Linux distributions with something called systemd. And I don't know when I want to give the systemd talk, but systemd is a big replacement for a lot like the border between like the boot and like the user space and the kernel space. And systemd is this very like modern, very complicated thing. And when I use Linux, that's what I use a lot. So that's what I like know the best. This is what I'm doing right now. This file is for older things like known as like init 5 or system 5. And that's actually what I'm building into my operating system to make it a bit like um, leaner. So I don't know actually a lot about, well, at least I didn't know a lot about how syslog worked and init worked before I started this. See, I could have said that while typing, right? I mean, oh wait, hang on a second. Okay, so I actually, you know what? I actually made this mistake on purpose. Let's go with that, and I will fix that in a second. Yes, John, you're right. And we're going to say that I did that on purpose so I can give another lesson. So don't tell anybody that this may not have been on purpose, but you're right. And that's actually what I said a second ago, and I was like, oh shoot. So this is so I made a mistake where all of these tildes are actually supposed to be dashes. So how can I fix all this? Because this kind of sucks. Because otherwise I'd have to like go and like change each of these manually. Instead, what I can do is that Vim has a feature similar to sed where I can do, if somebody can remind me, s. I think I can do the same thing, right? Where I can do s/this/that. I may need to like escape the hyphen or something. I don't know. No previous substitute regular expression. I can figure this out. I got this. Oh, it's supposed to be percent, right? Right? Percent, like percent s, right? Slash. I may need to escape. Like, do I gotta escape this? No previous substitute regular. Oh, come on. Do I have to escape this? There we go. See, look at that. So with this thing right here, what I did is that apparently tilde might mean something for the regular. I don't know what it means, but since that actually has a meaning that doesn't just mean tilde, if you put a backslash before it, it means like, think of this as literally just a tilde. So what this will go is that it'll go through the program and look at all the things that have tildes and replace that with hyphens. Only on the first line. Okay, cool. Tilde is used for steps. All right, I did not know that. Percent is the whole file. If percent is the whole file, does that make the G redundant? Or would it go through the whole file and only do it like once? Like just how like sed does it. Oh, it'll do it once per line. Oh. Well, I guess that would have worked here too, right? Because it only happens once per line. Okay, anyways. So sysklog, what I just installed, it comes with so it comes with two programs, klog and syslogd. So what klogd is that it's a system. Well, it's not even programs that you run. These are both daemons. But there's one that's klogd, which is the daemon for intercepting and logging kernel messages, right? So that's klog, so that's a kernel log. And the other one is syslog, which is logs the message that the system programs offer for logging. I'm developing only in Vim because it is a Yo, that's my man. Yo, Koopa, we're on the same playing field here. I mean, this Vim looks a little grim because I haven't like set up any configuration stuff yet. I actually can't because I haven't set up users yet. So like Vim wouldn't even know where to look for my home directory. Well, actually, I could set it up because right now what Vim is reading from is that it's reading from like the global like /etc/ I forget where it is, like stop Vim or no, it's like etc vimrc or whatever. It's somewhere. But there's like a profile. Oh, is it an etc/? Why aren't my tabs working? That's weird. Anyways, can you show the syslog.conf again? Yeah. Did I mess something up? See, this is where you come in handy because I'm a systemd guy. /etc. I looked in. Oh, that's the first place I looked, but that's before I noticed that my tabs weren't working. So I was gonna open it here. Okay, so yeah. Wait, will it work here /etc/? Okay, so for some reason I messed something up with the tabs because here the tabs are working, and then here the tabs aren't working. Whatever, that's fine. I don't know what it is. I didn't change anything in my environment. No, and it probably wouldn't be an env thing. It would probably be a readline thing. So it would be something with readline. I don't know what I changed. Whatever. Okay. Actually, no. Having tabs would be very nice. I'm gonna just like, oh, that doesn't matter. My bad. Okay. The sysv. When did I do that? Whatever. Okay. Hopefully my tabs work now. Yeah, they do. Sorry about that. Okay. Now maybe now is time that I should do the system. I have a longer systemd talk in mind. Where am I? Do I not have colors here? kind of wanted colors, you know what I'm saying? See, I can't have a bashrc either because I don't have, again, I don't have like a home directory or anything really. Um, okay, there we go. So now it's time that I'm actually going to install sys5 init, which I spoke about earlier. So what is init, and what does sys5 init do? So I don't know if I should go through the whole like Linux boot up process or just skip to where this comes in. So as a super brief preamble, when you boot a Linux machine, or actually most computers, it does some things in the beginning, including looking at a specified part, right? Like normally like near the beginning of like your near the beginning of like whatever storage you have in there, right? And it will point to a program that will tell the system where to find things to boot, right? So it'll look at this thing and go to this piece of code that's normally called like a bootloader. I'm probably getting this all wrong, right? And then the bootloader does some things, including, and like a BIOS. I forget. Well, I guess it would be the BIOS, right? And the BIOS will then look on your storage, right? Like let's say you have a hard drive, right? So it'll look on the hard drive for your operating system. And then what it does is that the first thing that it will then do, or actually where the kernel is, and then it will do like and at first, right, so everything will have to be in like RAM, so it will actually load like in an initial like RAM file system, right, like init RAM fs or whatever. It'll load. Oh man, I'm getting. See, I got to get better at explaining things. Okay, moral of the story. Okay, I'm actually gonna skip everything, and I'll get to that when I actually start working more on the kernel. What init is is that after the kernel is that it is the first user space, and I'll get into what the difference between user space and kernel space is in a while. Just think of like kernel space as like the stuff that talks to like the actual hardware, and that's very like it talks directly to the hardware, but then it also mediates things at like a high, like resource management and things like that, right? So after the kernel launches, it's a first user space program called by the kernel, which means that the init program, um, the you would call it like the library being the kernel. Maybe that's like I feel like that analogy is like you might if that analogy makes sense to you, you might already know like what I'm talking about. But anyways, um, so okay, now I'm going to summarize my summary. Okay, because I'm getting way off course here. Sys5 init, it's the first program that's run when you boot your computer, you can say, right? The first program run. And what that does is that it sets everything up, right? So when you turn on your computer, and it's actually, so when you turn on your Linux machine, or it's actually similar in like Mac OS because it has another similar init program called kernel task, but and like launchd, so everything that you see on the computer, right, this is specified by like your init program, right? Because that sets everything up. You turn on your computer, right, and then the init program runs, and it like spawns it like clones itself and sets up all like the shells and all the programs that run when you turn on the computer, right? That's what the init program does. Is that it sets up, is that it sets up your computer when you turn it on. Now there's different programs that will do this for you. The most advanced one and the standard one right now in Linux is called systemd. Systemd is a really cool program. And okay, so one more thing is that another goal of the init program, right, is that it sort of mediates in a lot of ways, it mediates interactions between like what the user is doing, like in their stuff, and what the kernel's doing, right? That's another thing. So systemd is really great at that. It has a lot of tools for providing this communication. Um, it has um, it has like a very streamlined way of doing things. It's sort of one program that does a bunch of stuff in because other implementations of like an init program are actually like a bunch of multiple like are many programs. Systemd is sort of like a one thing does it all, which is kind of cool, and it's also like very um, it's like pretty extensible and stuff. I'm not going to be using systemd. Systemd is the new thing. I'm going to be using an older thing called sys5 init, and it pretty much does the same thing as systemd, but different. It contains, so what sys5 init does, so it's all the things pretty much. Sys5 init is a package full of programs that controls the startup, the running, and shutdown of the system. So pretty much everything, right? So init. So when you think of what does init do, it controls the startup, the running, and the shutdown of your computer. And like the running, so that's pretty much the answer is init does pretty much everything, right? And I'm using this thing called sys5 init. So now let's like do that. So why the fuck is it? I don't know why I have installed two versions of sys5 init, but that's cool. Okay, tar jxvf. Well, I guess we'll go with the newer one, right? I mean, and then let's see what we got. So, where is my config at? That's what I'm looking for. Okay. Oh, there's no configure here. Okay, I just run it. Like I just make it. That seems kind of scary. I don't know if I want to do that, right? All right, I guess I'm doing that. The thing is that there are some bugs in the in this version. Okay, maybe that's why I had the older version, because apparently there's some bugs in this version of sys5 init. So I'm going to make a patch. So I'm going to fix those right now. Patch. Yeah, look at me. Well, is there something wrong with 2 point? Is that why I got 2 point? Maybe I read somewhere that I should use 2 point. Maybe I got 2.96 and then I read I should use 2.95, so I got that. I did all of this like initial setup stuff like dozens of work hours ago and like weeks ago. So maybe there is a reason I'm not doing this. Like maybe there was a reason why I had an older version too. Whatever, fuck it. Let's go. All right, there we go. So what this patch command does is that this will take a pretty much what this does is like if you have two files, right? You have like file A and you have, or yeah, okay, let's just say you have a file, right? And this file has a bunch of text in it and you want to change that file, right? How would you go about doing this like in a programmatic way, right? So there's this file, right? It has some text in it. But you want to change one word in that whole text document. And there's a bunch of people that have this text document, right? So one way that you could change that, so one way that you could distribute this new version of this text file, like let's say there's a typo, right? And you fix the typo, right? One way that you could distribute the fix is that you could just redistribute the whole file, right? So you have this 1,000-word text document. One of the words is wrong, right? But a bunch of people have the wrong version. So you fix it and then you just resend out that 1,000-word document to everybody, right? And then they just replace it and then, it's fine. So that works. But that's not very efficient, right? Because you just want to replace one out of 1,000 words but right? You just want to place 1 out of 1,000 words. Yet in order to do that, you're sending out a whole 1,000 words. Shouldn't there be a better way to do it? And there is, right? So one way to do it is with these patch files. So instead, in a patch file, instead of recreating and resending out the whole file, you just send out the changes, right? So let's say the problem, it's sort of like what we were talking about before with sed, right? Patch is actually very, very similar to sed. So let's say the problem is that in this 1,000-word document, the 489th word was YOUR, and it should have been YOUR apostrophe RE, right? So what you can do is that instead of sending out that whole document all over again, you could just make a patch file that says I forgot the number, replace the 498th word with YOU apostrophe RE, right? So that'll take the 498th word, which was YOUR, right? And then replace that with YOU apostrophe RE. Or maybe you could even make the patch file even more, even smaller by saying, instead of replacing the word, just remove the last character from that word and then append -re or something like that. So that's what patch files do. So if you look here, right? So this file that I patched, right, was a very big file. But if you look at the size of the patch file itself, right, it's going to be relatively very small, right? So look, so the format of the patch file is actually very readable because all it's saying, right, is that where it says, so this line, right, I'm guessing what this says is that we want to remove this line, right? So we remove these 2 lines and instead we add this line and this line, right? So what this patch file does is that it removes these 2 lines and then adds these 2 lines. And then it removes this line and it adds this line. And then it just adds, and then I think this is for like context. So I think it's saying like where this line is, right? So don't do anything to this line, right? This line is just made for reference, right? And then remove this line and remove this line and then add these 3 lines in there. As you can see, right, it's just going through and sort of, so as you can see, it's specifying, right? You can see here on the left side, right, so it's minusing these things and then adding these things. You should upload these videos to YouTube. This can be oh my gosh, maybe like after I do this, like maybe after I do Linux from scratch like 10 times, like after I spend 10,000 hours doing this, these videos might be good enough. But could you like, it's easier to watch boring stuff live. You know what I'm saying? Like some things, it's like, oh, you may be able to sit and watch this, like maybe it's like background stuff, or maybe because it's like I'm here doing this in real time, it's easier to do. But could you imagine like going onto YouTube and like selecting this video and like voluntarily subjecting yourself to that? Yeah, I mean, I don't think this is entertaining enough. I'm not saying this is even entertaining live because I mean I have like 4 people in here, so but I'm saying like, well, 4 people may watch it live, 0 people would watch it not live. But I'm trying. But I'm sorry. I shouldn't be like breaking down your idea because I can because I'm actually very flattered by that. Thank you so much. That actually really does mean a lot to me since I just got started with this. That is like just got started with streaming. That means a lot. Thank you. It's just that yeah, I don't think like as as like a streamer or whatever, I'm like, I don't think I'm at that level yet where I could, where I can make this super interesting. But for the you that are here, that is super cool. And then you can get the VODs like later. Like it does save the VODs on here. Yeah, messing it up is part of learning. True. All right. Anyways, so now I'm here. Where was I? Did I already patch it yet? Yes. Okay, I did patch it. Right. That's weird. There's no like configure stuff. Like there's already a make file here and I didn't have to configure anything. Like what's up with that? Yeah, I think I can just make it. It's pretty gnarly, right? Yeah, look at that. I can just make it. And that was fast. And does this come with a test? No? Okay. That's so bizarre. Like it doesn't come with any configure thing, and there's no checks for it. You just sort of freeball it. That's cool. And there's no like checks either. Like I feel like if one package should have a test, it's like it's this to make sure it works. Although it's hard, right? Because how do you test something that's running at this level? I mean, you can run you can test regular programs easy, but like how do you test init like on multiple times in edge cases without like having to reboot the computer or whatever? Whew. So, anyways, so sys5 init, it comes with a bunch of programs. Because unlike systemd, which is like one program that like does it all, systemd is a couple programs, and then it also takes advantage of programs you already have. So like for example, like one of them is like boot log, right? So this will log boot messages to a log file. There's the fstab decode, which lets you run a command that requires decoding fstab like arguments. There's halt, which will make the computer shut down. There's init itself, which is like, this is the big deal right here. Init, this is the first program to be started when the kernel has initialized the hardware. And then init, once the kernel finished initializing, init takes over the boot process and starts all the processes on the system. There's also kill all, which sends a signal to all processes, which is cool. Actually, I think kill all 5, because there's another version of kill all that I installed in the PS utils, but then kill all 5 is something else. So then there's the power off command, which I mean, I'm sure you know what that does. There's the reboot command. There's the run level command, which this reports the so the run level command reports the previous and current run level. I obviously haven't like used init yet at all, so it says unknown. There's the shutdown command, and there's the tell init. So what tell init does is that you can use this to change your run level. Okay, let's look at the chat. Yep, patch. No configure. Yeah, so that's cool. Grub is considered a kernel. I was under the impression grub was a bootloader. That's no, it's just a bootloader. It doesn't use any kernel. Yeah, it depends what you mean by like. I mean, you can use technically grub might have a kernel. Actually, grub probably does have a kernel, but it's not the kernel that's run by the operating system. Like so there's a difference. So a kernel is just the thing that distributes like that controls like the resources and communicates with the hardware. So grub, right, or something like noobs. To John Udar's previous comment, no configure for sys. BIOS NBR kernel / grub. Oh, I see. So when he said kernel / grub, I don't know what he meant by that. I mean, it would probably be BIOS NBR maybe, but then grub could be, well, no, maybe not. So then, okay, fine. So NBR, which makes sense. That's the master boot record. That's the part that like, that's the NBR is what looks at the file system and then sees like, oh, what should I boot from the file system, right? And then normally the NBR will go to grub, right? I guess maybe he's saying that because maybe you could jump to the kernel directly and just skip past grub and may not need it, but normally it would be like from the NBR maybe to your bootloader, right? And then from your boot, but you're right, from grub it would then go to kernel, right? So if grub has a kernel, right, then it would probably be like from NBR to the grub kernel to grub, and then grub will then hand off to the Linux kernel, right, which has nothing to do with the grub kernel, which will hand off to the Linux kernel, and then we'll run init. Yeah, I don't think NBR is a program. I think NBR is just what the BIOS looks for, like to then like the first program to run. Yeah, I mean, actually, speaking of like bootloaders and like kernels and stuff, just last night, check this out. I learned how to do this recently. All right, you guys who watch streams a lot may not understand, but when I figured this out, this was the coolest thing. All right, check this out. Check this out. Pro stream remove right here. Wow, that's sick. Okay, so look at this pro stream remove. All right. So, anyways, so I watched this last night. I can probably go through my history and find it, but and then what is it, like cloud or something? I'm trying to, yeah. So if you guys want to watch this video here, this is cool because he talking about using a Linux kernel as the bootloader for like for your OS. And pro stream remove, stand by. Oh wow. So what's going on in here is that he's saying that you can have like a you know, that if you were going to make a bootloader, a great bootloader would actually just be to use a stripped down Linux kernel as your bootloader, right? And which hands it off to then a more robust, like a full Linux kernel that's part of your operating system. So I saw that last night and I thought that was pretty cool. And by the way, if you are into like Linux and like learning about it, the guy that does this video, if you don't know about him, you should definitely like look him up and watch some of his other stuff because he's a very important person to the Linux community. Man, I can't believe like init's like such an important thing, and it's weird that it was like so easy to install. All right. So now we're gonna install the udev package, and what udev is so this contains programs for device nodes. It lets you create device nodes pretty much. And by the way, something that I super want to stress on this channel is that if you guys like, I barely know anything, right? So if there is something that you guys don't know that I'm talking about, like please ask me, because then like, again, I got to get better at like giving better answers and not getting like totally off and derailing the whole thing. But if you don't get something, or if you just want me to like you think you know something but you just like want to make sure, whatever, like definitely ask me, and then we can try to like I'll try to show you guys what's going on, and then maybe it turns out that I actually don't know what I'm doing, and then we can figure that out together. All right, so what exactly are the options for okay, so some of these are going to need like prefix. We're going to need that. Binder, sbinder, libdir. These are all things you're going to have to overwrite because these are going to be different. Let's see. The sysconfdir, libexec, a lot of dirs. Wait. Let's see, we're going to want to enable man pages. We don't want a root prefix. No root prefix. And then we want it to be dynamically linked. Okay, I think that's all. Sysconfdir equals. All right, is all this right? Yeah. All right, it's important to make sure everything here is right. All right, looks good to me. See, again, like, why didn't I explain, like, init and all this stuff, like, now? Oh, well, you know what? It wasn't that long anyways. But what if it was? What if it was? All right. So so this is an important package, and we're going to run some tests on it. In order to run these tests, we need to make some directories. Otherwise, the tests will fail. These directories aren't actually going to be used for things, but the tests are going to look to make sure that they're there. Okay. So all right. That's what I like to see. Hopefully I don't jinx it. Nice. Okay. That's good. So now we can install this. Do you guys know, I always do make J install. Do you know if that actually speeds things up? Like to multi-thread install? Like I guess I could look and like look inside of like top and see if there are being like multiple threads spawned by it. I haven't done that yet. I feel like it probably doesn't, right? Because like it's still writing. I mean, maybe it could help like queue things up. Maybe there's like a small increase, but probably not much. Okay, so what I did for part of this is that I got some. So I checked for Grub. It does not use any Linux code. It's structured around 3 stages, around 500 kilobytes. So it's just to load the stage 2. Just to load the stage set 2, set up memory stuff, load the core, basically UI and OS selection. There's no kernel here for drivers. Everything is handled by the software itself. Set up stage 2, set up memory. Huh. Okay. That's cool. So that's very interesting. But I mean, but there's still, so then it's weird, right? Because there may not be a kernel if you consider a kernel as something that is separate from like a user facing thing, right? But another way you could think of Grub then is that I mean it's made to be as minimal as possible, right? So it just sort of puts the kernel and it just puts the kernel and the front end stuff just together, like there's no separation between them. But there is stuff that's, I mean, you say that there's no kernel here, but there probably are drivers. I mean, I don't know where the drivers come from. I mean, they could just be, well, they're, again, it is communicating with the hardware, so it's using some sort of generic, I mean, it's probably using some generic interface for communicating with hardware, right? So in that case, what you call, and you say that all of this stuff is handled by the software itself, in which case it's kind of what I'm saying. In that case, the software itself is the kernel, but also the software is like the GUI. So it's like, so I think what Greg was talking about in that is maybe it might be better to have like an actual Linux kernel as opposed. But I mean, honestly, I kind of
don't really know what he's saying there, because I think grub is fine. Because again, your bootloader doesn't really matter. I mean, as long as your bootloader can find your kernel and can hand off execution to it, it's fine. Because like something that you guys should understand about bootloaders is that the bootloader plays no effect once the kernel is loaded. Like the bootloader hands off all, like it hands off everything to the kernel once that gets started. So your bootloader doesn't matter. So I don't think it matters what bootloader you use, as long as it like does its job. But that's cool. So pretty much what grub is that it doesn't seem to make that difference. Yeah, it's not in memory anymore. It's nowhere. It doesn't matter. Because I think grub's great, because it's like, again, it's very small, right? And it does what it's supposed to do. You don't need security in the bootloader, because you don't need that user space or whatever separation. Because I know if somebody has access to the bootloader, then, well, at least you don't need the kernel like security. I mean, I guess you do need some kind of just like, if it's like for like encryption or things like that, but I don't know. But no, if you're encrypted, it should probably be handled by the operating system, not by the bootloader. I don't know what I'm talking about. All right, what was the last thing I did? I installed it. Okay, so for this specific Linux for scratching that I'm doing, there's some extra rules and support files that I'm going to install. So all right, there we go. Let me just see something first. Okay. So now I'm going to configure this a bit. Oh, wait. Yeah, but it's not even in memory anymore. Yeah, the bootloader is running the equivalent of kernel space, if that makes any sense. Yeah, that's what I'm saying, because it's talking to the hardware. So I don't think you really need like an operating system for a bootloader. Okay, configuring. Okay, so now I'm going to configure this a bit. So information about, speaking of like hardware stuff, so information about hardware basics is maintained in the /etc/udev/hardwaredb.d file, right? And in /lib/udev/hwdb.d directories. And EUDEV needs that information to be compiled into a binary database called /etc/udev/hwdb.bin. So in order to create that database, we're going to use udev admin hardware db update udev adm hardware db. Okay, so there we go. So this comes with 2 programs and a couple of libraries and some directories. So the 2 programs you just saw me use is udev adm, which is a generic udev administration tool. It controls the udev daemon. It provides info from the udev database. It monitors U events. It can wait for U events to finish. It can test your udev configuration, and it can trigger U events for a given device. What udevd is that is the daemon that listens for U events on the netlink socket, and it can create, and what the daemon does is that it creates devices and runs the configured external programs in response to those U events. And then it installs the libraries that like does that stuff. So it installs like libudev, that is the library interface to the udev device information, and /etc/udev, which contains the udev configuration files, device permissions, and the rules. Yeah, the bootloader, I need to go. This was fun. I'll try to check your Twitch page from time to time. Have fun. Thanks so much. Thanks so much, John, for stopping in. That was really great. I learned a lot from you, and you were funny and stuff. So it's cool to have you here. Thanks again. All right. All right. So I guess I'm going to talk to you guys a bit about, so we're about to strip things. So before I strip things, I'm going to talk to you guys about stripping and about debugging symbols, just to explain this a bit. Or should I start first and then talk while it's working? I'll just talk first. Okay, so most programs and libraries are by default compiled with debugging symbols included, which is like the GC. Like, I don't know if you guys ever done like debugging with C before on Linux, but if you guys know about like obj dump and all that stuff, you know that you'll have to compile with debugging symbols included to make it like easier using the GCCG option. And this means that when debugging a program or library that was compiled with debugging information included, the debugger can provide not only memory addresses, but also the names of routines and variables. However, the inclusion of these debugging symbols enlarges a program or library like significantly. So, for example, bash, if you compile bash with debugging symbols, it's 1,200 kilobytes, right? Like 1.2 megabytes. That's insane. Like how big is GTA 5? Like, I don't know. I think they're similar sizes, right? But if you compile bash without these debugging symbols, it's only 480 kilobytes. So that's a lot better. Or glibc and GCC that I spoke about before, right? When you have the debugging symbols, and this actually is, it's 87 megabytes. So glibc plus GCC with debugging symbols is 87 megabytes, right? But without debugging symbols, it's 16 megabytes in total. So that's a big difference. So, and the sizes, and the differences between the sizes depend on which compiler and C library were used. But when comparing programs with or without debugging symbols, from what I see, it's normally like a difference between like 2 and 5. But because most users will never use a debugger on their system software, a lot of disk space can be regained by removing these symbols. So that's what we're going to do now. We're going to strip all the debugging symbols from the programs and libraries. Or should I do that later? I'm looking at the notes here. Trying to figure out what I want to do. Okay. I think what I'm going to do is, like, how long have I been streaming for? Can I see how long I've been streaming? Like, does anybody know how I get that to work on my stream? Because that would be pretty cool. Here, let's figure this out together. Hang on. I'm trying to do a pro streamer thing. Look at that. Can you guys not see the whole? Okay. Hang on. Okay. Is that part of the stream tools or whatever, Streamlabs? Okay. Uptime. Is that a thing? No. How can I get this? Twitch uptime. Oops. Oh, is that Nightbot? I don't have Nightbot. Uh, Wait, do I need to have Nightbot in order to do this? Yeah, that didn't fucking do anything. Alright, let's see this. Nightbot. Oh, that's so cool. Yeah, I want to sign up for Nightbot. I'll log in with Twitch. Edit your channels. Ooh, that's dangerous. Alright, now does it work? Maybe you gotta wait a second. I hope you guys can't see what I'm doing, right? I'm not doing that thing again. Yeah, how the heck does this work? Okay, commands. It says this is enabled, but then I say commands. Do I have to like mod it or something? Oh, I see. Hang on. Dashboard join channel. Nice. Look at that. Did that work? Maybe I gotta mod it. Oh wait, I gotta mod it, right? Yeah, I'm trying to get Nightbot to work. Okay, mod Nightbot. Alright. Yeah, I don't know anything about streaming, so I'm trying to figure this out, dude. He did join my channel, right? Top chatter, top commands. So they, like, one of them worked. But then if I do uptime, it doesn't work. Okay, well, it says that there's no custom commands, but that doesn't really matter because because this is a default command and it's enabled, right? Because it says disable here. User level everyone. Game. Oh, I like that option. That's cool. Yeah, I saw that. But if you look at what I'm doing, like in the stream, it's because it's not a custom command, but it is a regular, like a default one. Uptime, bitch. Because, like, for example, commands isn't there either. You know, like the exclamation mark commands isn't in that link. Because that's because it's a default command. And it's enabled. Look at that, see? But just not uptime. Do you know what maybe it is? Maybe it's because it's like this stream, you know? Maybe the way that it works is that like Nightbot joins your channel at the beginning of streaming and then it starts like figuring that out. So Nightbot can't figure out how long you've been up for if you join it in the middle of the stream. You know what I'm saying? I mean, if you create Nightbot midstream, it doesn't know when you started. That's what I'm thinking. That's my guess. Well, I guess I can figure out that next time I stream. Oh, regulars? Oh, that doesn't. Logs? Oh, hey, look at that. Oh, you can see uptime being called. but then it doesn't. Does it show like the result? Spam protection, timers. Oh, this is cool. Okay. Anyways, I think I may just need to restart the stream, but I don't really think the debugging symbols are of highest priority right now. And after that, I'm just going to do some cleaning up. Then it's going to be really cool. So probably next time I stream, I will actually be legit, because I've already installed the bootloader and all this stuff. So I think my system is just about ready. So hopefully by the end of next stream, I'll actually be legit booting into this, which is going to be awesome. And I'm really looking forward to that. So hopefully we can do that, and I will, I'm probably going to hop off now. Thanks so much, Blunt Test, for being here, dude. You've been you've been here for a long time, and you've really made this stream super enjoyable. For, like, most of my streams, it's like nobody there, but you've been here and like made this a lot of fun. So thanks so much, dude. I mean, that really means a lot to me. What time zone am I in? I'm in the Eastern time, so it's 6:40 p.m. right now. And when did I start streaming? I probably started streaming at like 2, right? Well, I can't do uptime. What kind of work do you do? I mean, I know that you do you still do like the bootloaders or whatever? Nice, we're in the same time zone. Gnarly. Nope, still no uptime. Yeah, same. So what do you do while working? Oh, cool. So what were you working on today? Oh, you're in marketing right now. Okay, cool. Do you get to do any coding for that? Nah, yeah. Oh, cool, cool. Yeah, yeah, I get that, like data science stuff. Well, yeah, thanks so much for coming by and stuff. So hopefully I'll see you again soon. You were just learning, working on Unity. Well, yeah, dude. Well, if you ever start streaming that, I'll definitely tune in. Yeah, see ya. Oh wait, I gotta raid somebody. I have one person in the chat. Hang on, hang on. Unless somebody else. Is there anybody else here that's been like lurking? Hang on, we got a raid. We got a raid. What is it? Temple. Give me 1 second. All right, I'm gonna raid somebody with my one viewer. That's gonna be the move. Um. Uh. All right, I found it. This is who we're raiding. Again, is there anybody else that just joined that want to say hi before we raid? All right. Thanks so much. See you again.